And welcome back to Backspace Academy. In this lab, we're going to be introducing you to the Cloud9 integrated development environment. And this is one of the options that you can use as a development environment on AWS. You can also use your own integrated development environment on your desktop. For example, you might use Atom or Microsoft Visual Studio. But the advantage of using AWS Cloud9 is that it's hosted on AWS and it's a browser-based application, which really streamlines a lot of the integration with EC2. So it's very easy to deploy directly from your IDE a development environment for AWS and to launch your code and run your code on that development environment. Now, before we start using Cloud9, we need to have permission to use it. So we need to go into Services and IAM, and we're going to select a group, and we're going to apply permissions to that group. So I'll just select here the Administrators group. We select Permissions, and we attach a policy. So we can see there we've already got our Administrator Access policy, but that doesn't include Cloud9 access, so we need to also attach that as well. So we click on Attach Policy. And the policy type will be an AWS managed policy. And we just type in Cloud9. And there we can see we've got an AWS Cloud9 administrator policy that we can attach. So we just attach that policy. And there we can see that is ready to go. So now all we need to do is go into our Cloud9 service. So again, we go into Services and Cloud9. And if you haven't created a development environment yet, then you'll be presented with a welcome screen. So we just click on Create Environment here. We'll give our environment a name. And we won't worry about giving it a description. We'll go to our next step. Now, what we're going to do is our environment, we're going to create an instance that we're going to use for our development environment. So when we're working on code, we can deploy it directly to an EC2 instance. The instance type we want to do is a T2 micro to be on the free tier. A very good feature of Cloud9 is the cost saving setting. So what that means is that if you are not using your IDE for 30 minutes, then your EC2 instance will go into a hibernation mode and you won't be billed for that instance. And then when you go back and you restart or you reuse your development environment, then that EC2 instance will then come out of its hibernation mode. So you don't need to go back and clean up all your EC2 instances like you would do if you're using a normal IDE and launching it, for example, from a GitHub repository or whatever. The Cloud9 service needs a role to access EC2, and so there is one there already. We also have a network setting, so we can select the VPC and subnets that we want to deploy our EC2 server into. For now, we'll just leave it as a default VPC, and we'll click on Next Step. And there we can see there's a summary of it. We've got our name, the environment type, it's a T2 micro, it's going into a default subnet, and it's going to go into hibernation mode if we don't use it for 30 minutes. And we click on Create Environment. Now, after a certain amount of time, we're going to see that our Cloud9 development environment will have been created. And we can just check on that if we go back to the console. So just jump back into the console and we go to Services, EC2. We should see a EC2 instance that has been created. So let's click on one running instance there we can see. And there we have our AWS Cloud9 Backspace Lab P Cody instance that has been created there. It's got a security group that has been created, and it's also got a public DNS. So, and a public IP. So that is really good because out of the box, we've got something that we can launch web applications onto, and that saves us a great deal of time. So let's have a look at the IDE itself. So we have a welcome screen here, and down the bottom here, we've got a console, and that is a console that's connected to that EC2 instance. So we don't need to use PuTTY, we don't need to use shell or anything to get in it. We have a shell environment here directly within the IDE that we can launch our commands into. If we scroll down here to the welcome screen, we can see that we can actually configure that with different, dark theme, a grey theme, whatever we want. We also have more settings here. So we have a look there under more settings, and we can see we can change that the EC2 instance to stop it after 30 minutes or 10 minutes or whatever we want to do. We can see a number of options for the code editor. Now the code editor is ACE, which was formerly from memory called Mozilla Skywriter. So AWS have picked this up as an open source project and are developing it quite further. So it's got some great JavaScript support in there. It's got PHP, Python, Go. It's really good. And what I'm noticing with this is it's growing very rapidly. So I'm not going to talk too much about the settings in here because obviously it's very much a work in progress, and over time it will get more and more advanced. So I'm just going to run some commands in that shell environment down below. So the first thing I'm going to do is just check if Node has been launched or has been installed. So just going to copy that over from the lab notes. Now, if we right click and we do paste, it doesn't work. If we go here and we do edit and paste, it's not working either. So some browsers it will work, some browsers it won't. So the only way I can get it to work from here is to do Control V, and that will bring that in. And so there we can see it's already installed Node out of the box for us at version 6.12. So the next thing we can do now is install the AWS JavaScript SDK onto this instance. So let's just quickly do a sudo yum update to make sure that our Linux operating system is up to date. So that's completed. Now we can install the JavaScript SDK. Okay, so that's done. So now we're ready to run code on this EC2 instance. So what we'll do is we'll do File, New File, and we're just going to do a hello world or console log hello world. And then we'll save that. So file save as, and we're going to call it just hello.js. Okay, so you can see there it's formatted that nicely with the color coding on our editor. All we need to do now is we can run that directly from here by just clicking on Run. And there you can go. In our console screen, it has completed and it's console outputted hello world. So we've just run our first Node.js application on this instance. And we'll just Control C out of that. So I'll just close that file and I'll just delete it by going back to the console down the bottom here and just doing an rm command to remove hello.js, and it's gone there. So let's do a little bit more complicated application. So what I'm going to do now is just clone a repository that has just a sample Node.js application. So the details of this are in the lab notes. Just do a dir on that to see that worked. So there we can do. We can see we've got our Node.js sample application there. We'll cd into that. Okay, so we'll just do an npm install and then start it. And an npm start. So there we can see we have a Node app running at localhost 8080. Now the easiest way to view our application in the browser is to go at the top here and do preview running application. And there we can see it's our hello world has output there. So our Node app is running and we've got it there on the wider internet as well. So let's have a go at editing this application. So we'll go into Environment, and there we can see we've got our directory tree there. So we go into Node.js sample, and we can go into our index.js application there. And what we'll do is we'll just go in and change the message there. So hello world from backspace. And we'll save that. And we'll run that again. And we refresh the screen. And we can see there we've got Hello World from Backspace Academy. So that's a pretty simple and easy introduction to Cloud9. I would strongly recommend you use Cloud9 if you want to get through the course quite quickly and you don't want to muck around too much with setting up an IDE and having all the connection issues and all that. If you want to just jump onto a browser and start writing code and launching applications, this is going to be the quickest and easiest way to do that. So before we move on, I'll just clean up this environment and make sure that it's ready to go for the next lab. So we just go into Backspace Lab P-Cody again. And we can remove these. So we just delete. And delete that as well. And we'll delete that README as well. Okay, that brings us to the end of this lab. I'll see you in the next one. And welcome back to Backspace Academy. This lecture, we're going to talk about encryption on AWS, which is a very important subject. Now, I deal with a lot of senior IT managers for quite large companies, and a lot of these people just don't really understand encryption. And it's not their fault. The problem is the way that encryption is taught can be confusing. So what I do is that I will break it down into very simple building blocks. And from there, you will build and further understand how that applies to AWS. And I promise you, at the end of this lecture, you will well and truly get encryption on AWS. We'll start off by discussing the two main types of encryption, being symmetric and asymmetric encryption. We'll talk about the key management service that integrates with many AWS services. We'll talk about the Cloud HSM service that can allow us to securely store and manage our encryption keys. We'll talk about the Secrets Manager, which can be used for storing our secrets that are in text files. For example, our username and password. We'll talk about the AWS Encryption Software Development Kit, specifically for cryptographic operations. And finally, we'll talk about how we can encrypt our data on AWS, both at rest and in transit. Symmetric encryption. Now that uses the same encryption key to both encrypt our data and to decrypt our data. So that requires our sender, who is going to be encrypting our data and sending it, and the receiver, who is going to be decrypting our data. They need to agree on the same key and keep it safe. They need to keep it secret and secure, because if that key is intercepted in transit, or it's stolen, or some other way it has been compromised, then that data can be compromised as well. Now, to understand asymmetric encryption, we need to understand the concept of a two-way lock. So the easiest way to understand this is to think about, we've got a padlock here, and that padlock has two keys. Now, one of those keys turns the lock in a clockwise direction, and it locks that lock. And if you try to turn the key in the anti-clockwise direction to unlock that lock, it won't let you do that. But if you use your other key, now that key only turns in the anti-clockwise direction. And so you can put the other key into that lock, turn it anti-clockwise, and you will unlock that two-way lock. So one key can only lock, it can only go in one direction. The other key can only unlock. And so what we have is that we have a public key, and that is used to lock that lock. It cannot be used to unlock that lock. And then we have a private key. Now that private key can be used to unlock that lock, but the private key cannot be used to lock the lock at all. So asymmetric encryption, which is also sometimes referred to as public key encryption, uses a pair of keys. A public key that is only used to encrypt your data, and a private key which is only ever used to decrypt your data. Now, the public and private key are mathematically linked, but if you have the public key, it's not possible to mathematically work out the private key. You just wouldn't have a computer with enough resources to carry out that massive algorithm to do that. So it's not possible to actually create one from the other. So you may be wondering, why do we have a public key and why do we have a private key, and what is the purpose of that? So anyone who has this public key can encrypt that data for the receiver. So if you want people to send you some data and encrypt it before they send it to you, what you can do is that you can send them out your public key, and they can use that public key to encrypt that data before it is transmitted over to you. They never receive the private key. That private key is kept with you, the receiver of that data. And you use that private key to decrypt the data. And that is great because that private key never leaves you. And so if that public key, which is sent out to the transmitter, if that is ever intercepted, it is of no use to anyone because a public key can never be used to decrypt data. Only a private key can. And that is the magic of asymmetric encryption and why it is so important. Okay, so let's have a look at a real life example. Let's just say that we've launched an EC2 instance and we want to connect to that instance using Secure Shell or SSH. So the first thing that we need to do is obviously we'll need to make sure that our security group rules allow a connection on port 22 for SSH. The other thing that we need to do is that we need to make sure that we download the PEM file for connection to that EC2 server. Once we've got that, then we can go through the process of connecting to that EC2 server. The first step is that we need to make sure that we're running our SSH client on our computer that we're connecting to from our office or home or wherever it is. And once we've got that SSH client and we've got the endpoint for our server, we can initiate a session with that EC2 server. Once we've done that, the EC2 server will provide us with a host key, and that host key will be our public encryption key. And that will occur when we attempt to connect with that EC2 server. So once we've got that public key and we've got our PEM private key, we can use asymmetric cryptography to verify the identity of that EC2 server that we're connecting to. Once that's done and once we're satisfied and the EC2 server is satisfied with our identity, then this server will generate a symmetric key, and we use that symmetric key for bidirectional encryption from that point onwards for that session. And that way, all of the traffic being sent to and from this EC2 server will be encrypted while it is in transit. One very important thing to remember is that what happens if you lose your PEM file? If that occurs, you will not be able to connect to your EC2 instance, and AWS will not be able to provide it for you because that is your private key and only you have a copy of that. AWS does not keep a copy of your private key. So in that situation, what you are going to have to do is that you will have to stop that instance. You will have to create another private key or another key pair. And then you're going to have to associate that key pair by going into the user data, quite a complex process, and associate that new key pair with that EC2 instance. And then you'll be able to use your new key pair to connect in. The AWS Key Management Service, or KMS for short, that integrates with a lot of different AWS services, and it creates and manages the encryption keys that are used with those services. It uses a single master key that is secured by AWS. So it is symmetric encryption. We don't have a public and private key. We just have a single key. Now that key always remains on AWS and you cannot download that at all. The key is rotated automatically by the KMS service every year by default if automatic key rotation is enabled. If you want to use the KMS service to encrypt any data, then you must have IAM permissions to use those keys. And so those permissions can also be granted to other AWS accounts as well if they would like to decrypt that data. Now, the list of services that integrate with the KMS is growing, but if you go to the Amazon website and go to /KMS/features, you'll get a good list of all of these services that integrate with the KMS. Because the KMS service uses symmetric encryption, you may be questioning the security of that, but there's no need to be alarmed because we have another process involved with the KMS, and that is called envelope encryption. So the way that works is that we have a data key that is used to encrypt that data, and that is our single encryption key. Now, to make sure that that data key is secure, so if someone gets hold of that key, what the KMS does is it actually encrypts that encryption key. It encrypts the data key using a KMS master key. And so those master keys are stored by AWS and they're called your customer master keys, or CMKs for short. Now, although symmetric encryption with a single data key is being used to encrypt that data, the KMS service can actually support symmetric and asymmetric customer master keys that are going to be used to encrypt that data key. And those CMKs are stored in a FIPS 140-2 compliant hardware security module, so they are very safely kept. If for whatever reason the data key is compromised, it's not a problem because it's encrypted using that master key. The AWS Cloud HSM service is a cloud-based hardware security module, or HSM for short, and it is used to secure and store your encryption keys. And it conforms with the security requirements for cryptographic modules, Federal Information Processing Standard, or FIPS for short, 140-2 Level 3. What that means is that your encryption keys that are stored in this HSM module are extremely secure. You control and manage your keys. AWS does not have access to your keys. And it's only accessible, these keys are only accessible by users that you specify. The Cloud HSM will run inside a VPC inside of your account. The encryption keys that are stored inside of that Cloud HSM will be accessible by a HSM client application that is running on an EC2 server that you launch. And there are HSM commands within the AWS software development kit. It's also multiple availability zone capable as well. Some use cases for Cloud HSM. You may want to use a Cloud HSM cluster as a custom KMS key store instead of using the default KMS key store. You may want to do that if you want to keep all of your keys in the one location using Cloud HSM. Another use case, you can use it to offload the SSL processing from your web servers over to Cloud HSM. By doing that, Cloud HSM will take all of that processing for the HTTP requests and take that load off your web servers and make sure that your web services are more available as a result of that and reduce the latency as well. You can also use it to protect the private keys that you use with a third-party certificate authority. So if you're using another service other than AWS to issue your SSL certificates, then you can protect those private keys using a Cloud HSM as well. The AWS Secrets Manager is a cloud-based service to store our secrets. And that could be database credentials such as a username and password for logging into a database. It could be our passwords, third-party API keys. It could also be arbitrary text that we can put in there as well that we'd like to manage as a secret. The big advantage of doing that and using the Secrets Manager is that we can replace hard code credentials that we've put in our code. For example, we may have a application that is a web application that's running on an EC2 server, and we may have put hard-coded credentials inside of that code to connect to something else. And so that's a problem. If someone manages to get hold of our code, they've also got hold of the credentials as well. So instead of doing that, we can replace that with an API call from that web server over to the AWS Secrets Manager. And then the Secrets Manager can authenticate that server and then hand over that secret to that EC2 server. It uses the AWS KMS service to encrypt the secrets, so they are encrypted and secure. The secrets can be created and retrieved using the AWS console, the AWS CLI, or one of the many software development kits. To create or retrieve a secret from the Secrets Manager, you will need to have IAM permissions that will allow that to occur. Okay, here is how we would create a secret using the command line interface. The command there is Secrets Manager, and then the command there is create secret. And then we need to provide a name for this secret, a description for it, and then the actual secret itself. So we can see here we've got a secret-string, and then we define what that secret is, and it's a file. So the details of that secret will be in a file called mycreds.json. If that was successful, the command line interface will then output the ARN or Amazon resource number for that secret and the name that you provided for that secret and the version ID of that secret as well. The IAM permissions that are required will be Secrets Manager, create secret. And if you're using a customer managed CMK, then you will also need to have KMS, generate data key permissions as well. Now, if we want to retrieve that secret value, we'll need to have the ARN or the name that we provided for that secret. And we, of course, will need to have IAM permission. So we'll need to have Secrets Manager, get secret value. And again, if we're using a customer managed CMK with the KMS, then we'll need to have KMS decrypt permissions as well. So the command there will be AWS Secrets Manager, and then get secret value, and then secret ID, which will be either the ARN or the name that we provided for that secret. The AWS Encryption Software Development Kit and its associated command line interface is a client-side encryption library. So what that means is that you will install the encryption command line interface on a computer, could be an EC2 server, could be a remote computer, whatever it is, or you could install an application that is running the encryption software development kit as well. Now, this is separate from the AWS command line interface and the AWS software development kits. It stands on its own as a separate application. It supports only symmetric CMKs, but it uses envelope encryption to make sure that that encryption key is secured. Okay, let's have a look at an example using the command line interface. So the command there is AWS-encryption-CLI. And the parameters that we need to provide, first off, is encrypt, saying that we're going to be encrypting this data. We then need to define the input data, and there it is a file, hello.txt. We then need to define the ARN, or the Amazon resource number, for our master key. We then define a folder where we can store our metadata output. Now, the next one here is encryption context, and that is optional, but it is recommended by AWS. What that is a name value pair, or you could put multiple name value pairs in here. You just need to separate them with a space, and they further define this encryption job. So when we go to decrypt, we can also provide this encryption context in our decrypt command, and that will make sure that we're getting the right file to decrypt. So here we've got a name value pair of department and IT. And finally, we just need to define where this is going to be output. So we've just got there output and a dot, which will output that to the actual folder where this command is being issued from. And so that will create an encrypted file, and it will put that into the folder where that command was actually issued from. And that file will be called hello.txt.encrypted. Okay, when we want to decrypt that file, the command there again is AWS-encryption-CLI. And the parameters there are, first off, decrypt. To decrypt it, we provide what the input is, and there it will be hello.txt.encrypted. And that is the file that is encrypted that we need to decrypt. We will supply the encryption context if we supplied an encryption context previously when we encrypted it. If we don't, or if we didn't, then we don't need to worry about that. We need, again, to provide an output folder for the metadata, and then finally where we're going to output that to. When we run that command, it's going to create a decrypted file, and that will be called hello.txt.encrypted. So the same name as before, but with a dot decrypted on the end of that file name. There are three main options for managing your encryption keys. The first option is where you control everything. You control the method of encryption, for example, AES, whatever, and you control the key management infrastructure, or the KMI, and that will consist of the key storage, where that key is going to be stored, and the key management. So who is going to be authorized to access that key. And you are the one that controls all of that. AWS will not be involved in the management of that key. A good example of that is using client-side encryption, where you would encrypt your files before you upload those to AWS. So you have your computer here and you run an encryption client software. It encrypts that data, and then you can upload that data to S3, and that will be uploaded as encrypted data. AWS doesn't look after any of that encryption whatsoever. All it does is it stores that encrypted file for you in S3. The next option is where you can control the method of encryption and the key management, who is authorized to access that key. And AWS will look after securely storing that key for you. A good example of that is to use the Cloud HSM service to securely store your keys inside of a VPC inside of your account. And then your applications that are running on EC2 can access the Cloud HSM and then access that key. The last option there is where AWS controls everything. So they control the method of encryption and the entire key management infrastructure, such as the storage of those keys and the authorization of who can access those keys. A good example of that is to encrypt an S3 bucket using server-side encryption and using a KMS managed key. That way, AWS will be looking after all of the encryption, and they will also be looking after who can access that key and also looking after the storage and management of that key as well using the KMS service. We can use encryption with a lot of the AWS storage services. First up there, we can use the AWS backup service to manage all of our encrypted storage. We can also use encryption with the S3, Glacier, EBS volumes, EFS volumes, CloudWatch logs, Snowballs, Storage Gateway, CloudTrail, and also with code commit, code deploy, and code pipeline. But with code commit, we can only use it with KMS managed keys only. We can also use the AWS KMS service to encrypt our databases as well, including RDS, Aurora, DocumentDB, so those MongoDB databases, Neptune, the Graph databases, Elasticache, the database migration service jobs, and also DynamoDB. We can use it with server-side encryption for encryption at rest of that data. But we also have another option with DynamoDB, and that is to use a DynamoDB encryption client. And that allows us to encrypt that data both in transit and at rest that is residing in DynamoDB. Other AWS services that can be encrypted using the KMS, Kinesis Streams and also Kinesis Firehose, SNS, SQS, SES, Elastic MapReduce and SageMaker jobs as well. Now, this is not an exhaustive list of all of the services that are available to be used with the KMS, but if you want to get the latest and complete list of all of the services, just go to the Amazon website or the AWS website /KMS/features. So that brings us to the end of the encryption lecture, and I'm sure you fully understand it by now, and I look forward to seeing you in the next one. And welcome back to Backspace Academy. In this hands-on lab, we're going to be running through how to create an encryption key using the KMS service and then use that key to encrypt data. So make sure that you've downloaded the lab notes that come with the course. Now the KMS service, it's located in the IAM management console. So if you look for KMS here, you won't find it. You need to go to IAM. And from there you can scroll down and select encryption keys. So you can see here I've got some encryption keys, but they're all being created by different AWS services like Cloud9, S3 and all this sort of thing. So you can see those ones with the Amazon logo next to them. They're not ones that I have actually created myself. So what we need to do is create one ourselves that we can use to encrypt data with. So we create a key. Let's give that key a name. And we won't bother about a description with it. And we click on next step. And we won't worry about putting a tag in. We don't need that for now. Okay, so we need to select some administrators. So I'm just going to select myself as an administrator. And we also need to select some people that can use this key to encrypt data. So I'm just going to select myself again. And next step. So there's our key policy, and we click on finish. And that's how easy it is to create a key to use on AWS. Okay, so now that I've created that key, I can use that key to encrypt data in Amazon S3. So what I'm going to do is jump into the S3 management console. And I'm going to create a bucket. So I'm just going to give this bucket a name. And I click on next. Okay, so now we've got some options here available. So if we scroll down, we can see automatically encrypt objects when stored in Amazon S3. So that's what we want to do. So I'm just going to click on that. And what we want to do is that we're not going to use the AWS S3 managed key. We're going to use the KMS key that we created. So we click on KMS. and we select our key that we created. And there it is, test key. And we'll save. And there we can see. So we've now got that set up, and we click on next. And I'm just going to leave this as private. I won't change the permissions of it. And there we go. So we can see here now, when we look at the properties of it, we can see here we've got default encryption, AWS KMS. So we'll create that bucket. So I'll just jump into that bucket now. And we're just going to upload some files. So I'm just going to grab a little file and upload it. Okay, so just going to upload one of our review PDFs. And we've got some options here for permissions. I'll just leave that all as private. Okay, so now we can select whether we want this to be encrypted or not. And so we can see here, we can select the AWS KMS. I'm going to leave it as none because I want to see what happens if I upload this and tell AWS not to encrypt it. So let's go. We'll click on next, and we can see here we've got encryption. No. So let's see what happens. So I upload this. Okay, so that's been uploaded. So if I click on that and I have a look at it and we look at the properties, we can see that in fact it has been encrypted. So even though we told the S3 service to upload this without encryption, it has automatically encrypted that for us because we have defined at the bucket level that anything that goes into this bucket must be encrypted. And if you make a mistake and don't select encryption, it doesn't matter. It will be automatically encrypted when it goes into this bucket. So what I'm going to do now is just download that. And if I click on that, what will happen is that it will be downloaded unencrypted or decrypted. So what that means is that the S3 service has managed everything for us, and we don't really have to worry about that at all. And the KMS service has supplied the key, and it's all quite transparent for us. So that's just how easy it is. So what we do now is we've finished up with this lab. So what I'll do is I'll just clean it all up. So I'll just go back to the main index of Amazon S3, and I'll just click on that and delete bucket. Okay, so the bucket's been deleted. So what we need to do now is just get rid of that key. So we can't just delete the key. We can delete the key, but we can't do it in one hit. So what we need to do is go to Key Actions and Schedule Key Deletion. We can't just do it instantaneously. And we just had to put a waiting period in there. So just put in 7 days and schedule that deletion. And in 7 days, that deletion will occur. So that brings us to the end of the lab. And I hope you enjoyed it, and I'll look forward to seeing you in the next one.
I developed a number of Cognito tutorials on Node.js, on PhoneGap, Cordova, browser, whole heap of stuff, and it was extremely popular. Cognito was very, very popular, and I received thousands upon thousands upon thousands of hits and literally hundreds of emails over the last few years on Cognito, helping people out. And that was great. Now, one thing I would say about Cognito is that parts of it are great and parts of it are not so great. And over the last few years, it kind of has progressed at a rate of knots, and they're introducing a lot of what appears to be cool stuff, but not stuff that you really need and not stuff that really works out well. And if you have a look at the user forums for AWS and have a look at the Cognito issues that are out there that are unresolved, there's a lot of them, and a lot of them are around these additional SDKs that they've created. We've got, we don't just have the AWS JavaScript SDK, we also have the AWS Cognito JavaScript SDK, the AWS Cognito ID JavaScript SDK, the AWS Cognito Sync Manager SDK, we have the AWS Amplify SDK, we have the Android, oh my God, we've got them everywhere. Unfortunately, you don't really need them, and if you want to avoid all those difficulties, just use the JavaScript SDK. This is a course on development for certification, and you need to know how to use the AWS JavaScript SDK. It is what I use. I do not use AWS Amplify. I do not use any of this other stuff because I want to know what works and what works reliably. And so what I'm going to do is lead you through this landmine, because if you have a look at here at the documentation, a lot of this stuff just doesn't work. The JavaScript code that is in this documentation does not work. And when you look at AWS Amplify, there's a whole heap of issues around AWS Amplify. But the good thing is that they've kept a JavaScript SDK in there, and for the most part, that does work. So if you're looking for documentation on Cognito for JavaScript, go to the AWS Amplify GitHub page, and I'll just get that up here. And then navigate to Packages, and then go to Cognito Identity JS. And that will give you the JavaScript SDK that is current and is being used by AWS Amplify. And that's the one that you should be using if you're going to be using a Cognito JavaScript SDK. But that said, a lot of times you will find that the standard AWS JavaScript SDK, which has all of the services for AWS in it, does perform better. So I use a combination of both. AWS say just to use the Cognito Identity JavaScript SDK, and then they're saying now that, you should use AWS Amplify, despite the fact that AWS Amplify has a whole heap of issues. What I'll do is I'll show you how to use this Cognito Identity SDK, and then for the rest of it, we're going to use a standard AWS JavaScript SDK, and we're also going to use that for the Cognito Sync service as well, which has its own SDK as well, which you don't need. Okay, so here we are in the Amazon Cognito console. We've got two options here: manage your user pools or manage your federated identity. So just scroll down here, we can see that the options available for us. With user pools, we can add sign up and sign in capability for our applications using user pools, and that information will be managed and authenticated with Amazon Cognito on AWS. We also have federated user identities, and so what that can do is it can provide temporary credentials to enable our federated users to access our AWS resources. That could be not only from a Cognito user pool, but it also could be from Facebook or Twitter through an OAuth process as well. We also have the Cognito Sync data store, which enables us to store key value data across our devices, and that will be managed again by AWS. So the first thing we need to do is to create a user pool, and we won't be doing any federated identities with Facebook or anything like that. We'll just use Cognito to sign our users in. So the first thing we need to do, manage our user pools. We'll create a user pool, and then we click on create a user pool. We'll give it a name. So once we've given it a name, we can step through our settings. We can just use the defaults. We won't do that. We want to learn here. Plus we do want to make some changes to the defaults. So we'll just step through these settings. So the first thing we've got here is how do we want our end users to sign in? So we can get them to sign in with just a username and password, or we can also get them to use a verified email address as well. So instead of just typing in their username, they can still do that. But if they forget their username, they can always put in their email address. So that's probably a good one. We won't worry about using a verified phone number or a preferred username. So we can actually have it signing in with a preferred username if we would like. But we'll just leave it like that so they can use their username and their email address. Next we have a standard attributes that we can attach. So when they sign up, we can get information from them. So the first thing that we are going to get is going to be an email. We're also going to grab a preferred username. So instead of just giving them a username, we'll give them the opportunity to choose a username and to type that in. That's always a good thing. We'll select birth date, probably a good thing to grab, family name, gender, given name. What else can we put on there? We'll put the website on there. And I think that'll do us for now. So now we'll scroll down to custom attributes. So if what we're collecting there is not enough for us for a profile of this user, we can add a custom attribute there. So just say, for example, it might be a professional site and we want to get their LinkedIn page as well. So we can do add custom attribute here, and we're going to put in LinkedIn, okay, all lowercase. We'll click on next step. Next we'll have a look at what password strength do you require. So we can see here we require numbers, special characters, uppercase. We'll leave that as it is, minimum 8 for length, that sounds okay. Do you want to allow users to sign themselves up? So we can have the opportunity for them to sign themselves up, which you would probably use, or if you just want to have a private access and you only want administrators to sign people up, then you can have that as well. But we're going to allow anyone to sign themselves up. And if administrators sign up, you want those to expire how long? And so we're just going to leave that at 7 days. So they don't expire, they sign themselves up, but if you sign someone up and they don't sign in, then we can delete those old accounts quite quickly, or those old users in our user pool. Click on next step. Do you want to enable multi-factor authentication? Great, we can do that if we want. We won't for this, it's just a simple website. So, but that capability is available for us. Do you want to require verification of emails or phone numbers? So yes, we're going to be using an email to log in, and we want to, if we're going to sign people up, we might as well get their email address. And we need to provide a role to allow Amazon Cognito to send SMS messages. Now we don't need to worry about that because we haven't got multi-factor authentication done there, so we don't need access to a SMS service. So we don't need to worry about that, just leave that as it is, and we'll just click on next step. Now when someone signs up, they're going to receive an email verification because we've told Cognito that we want all these emails to be verified. So they can send a verification code. So when someone signs up, a message will pop up saying enter your verification code, and then they go back to their email address and they get that verification code, type it in. I think that's a little bit of work, so we're just going to use a link. So when they sign up, they'll receive an email with a link. They automatically verify their email for them. So we can customize this. So your verification link for. We can customize our SMS messages, and we're not using SMS here, so we're not going to worry about that. We can customize our email invitation messages if we want. Do you want to customize your email address? So normally it will just come with a random, or not a random, but a generic email address, no reply to whatever. So you can actually put your own from address or reply to address in there. We won't worry about that for this, and we'll click on next step. Do you want to add tags to this user pool? We can add tags if we want to keep track of things. We're not going to worry about that here. Do you want to remember your users' devices? We won't worry about that either. And which app clients will have access to this user pool? So what we're going to do, we are going to have an app that we're going to be using that will be accessing this user pool. So we need to actually grant access and build a relationship or a trust between that application and this client, this user pool. So we add an app client. We're going to give that a name. Now we don't do generate client secret. We keep that off. We don't need that. It'll just stop our application from working. So we just leave it at that. Give it a name and create that app client. Now we also have the option of having customized workflows with triggers. So we can actually implement a trigger that can implement a Lambda function to go ahead and do something. So before we sign up, we can have a Lambda function that has to do something, ask them to enter the words Kalamazoo or whatever it does. So we can make that happen, and we have pre-authentication. So we have a whole heap of triggers that we can introduce into that workflow, which provides a lot more power for our authentication service. But we're just going to leave everything as it is, and we'll click on next step. So we can just review it now, which looks fine, and create pool. So user pool was created successfully. It was quite easy to do. Now the next thing we need to do is to modify some of this stuff here. So we need to go into app client settings and click on that. and we need to add Cognito user pool. We can do a sign in and sign out URLs, so the callback URLs, we'll just leave that as it is and save the changes for that. What we can do now is choose a domain name as well for our application. So I'm just going to call this one backspace-lab and check the availability. So it needs to be something that's unique. This domain is available, so if you try and use backspace-lab, it's not going to work for you. It's just like an S3 bucket. It needs to be unique, so use backspace- your surname or something like that. So just save changes. Now that we know that's, and it will say the domain has been successfully created. So now that that's all done, we now need to go in and do our federated identities, which we will do in the next part. Okay, now before we get in and start creating our federated identity pool, we need to actually create our website, or create a bucket for our website, because we're going to need that bucket name in an IAM role that we need for this federated identity pool. So we're just going to go into the S3 management console, creating a bucket, just going to give that bucket a name, and just click on next. So I'm racing through this very quickly because we already know how to do this. So next again, make sure that we have public access on this bucket, so public read access. Next, create bucket. So once that bucket has been created, we just go into it. And the first thing we need to do is change the permissions on that bucket. So we need to have cross-origin resource sharing enabled on this, and we need to have a policy set up for that. The reason being is that our application is going to be on the browser side, and it will be accessing multiple domains through that browser, so the browser will block that from occurring unless CORS is set up. So we click on CORS, and there is already a sample policy there. We're not going to use that one. I'm going to use one that I prepared earlier. Okay, so I've just copied and pasted that over from the lab notes. So we can see there we've got get, put, post, delete. All of that is going to be allowed for cross-origin resource sharing on this bucket. Once we've done that, we need to go in and upload our website. So we need to, first off, there's a link for the Backspace Academy repository on GitHub for this code. So you just go to that and clone that or download it. Or if you'd like to work on it and send me some pull requests and tidy it up a little bit and make it look a bit more pretty for me, you can always fork that, and I'll take any pull requests quite happily for that. So clone that, download it, and open that up into a folder somewhere, and get that ready to upload onto your bucket. So just going back in there, we upload, and we're just going to drag and drop those files across. And again, we make sure that that's public permissions, so grant public read access, and we'll upload that. Okay, so our website is uploaded and all ready to go. So we just need to go into properties and enable static website hosting. Again, we know how to do this. Use this bucket to host a website. We're going to put in our index.html file for that. And I'm just going to click on the endpoint to get that open. It won't work because we haven't enabled it yet. And click on save. And go back to the overview there. Now I'm just going to refresh that URL for the website, and it should come in. So what's basically happened there is that there is a little bit of a spinner image that appeared there, and that's going to be up when the JavaScript SDK is coming into the browser, when it's loading that JavaScript SDK. And it'll only do that once, because after that it'll be stored in browser memory. And while that's occurring, these buttons will not be visible. And the reason I've done that is that because we don't want to click on any of these buttons and have any attempt at running code until that JavaScript SDK has fully come in. So that's all we need to do for setting up this website. So just going back into the GitHub repository for it. So we've got an index.html file there, which has just got all those buttons and whatever. We're not going to be doing anything with that file, But what we're going to do is, if you look at the JS folder here, there will be an app.js, and that will be a starting point for our application. So we'll have some basic stuff there for the user interface, and we're going to build up the code that we need for using Cognito. But if you're lazy or you've got lost and it doesn't work, there is one here called app-final. So all you need to do is rename that to app.js, and you can just run it without too many difficulties. You'll just have to go in there and change, obviously, your user pool ID, your client ID, your identity pool ID, your bucket name, all this sort of stuff will need to be changed for you as well. Otherwise, it won't work, of course. Okay, so that's all we need to do now for that. And what we'll do now is we'll create this identity pool. So we'll just go back into user pools and click on up the top here. We've got federated identities. And it just jumps straight into a getting started wizard. So I'm just going to give that a name. Oops. Okay, so we've got unauthenticated identities here. So we don't want to allow unauthenticated identities for our application, but we could, if we wanted to, we could have that happen. What we want to do is we want to use authentication providers. Now, we're going to be using a Cognito user pool to authenticate our users, but we don't have to use Cognito. We can use Amazon, log in with Amazon, Facebook, Google, or any OAuth process that we would like to use. We can also use SAML. If we've got an enterprise SAML application that we want to integrate in with it, we can do that with Cognito, not a problem. And we can also have a custom one. We can do our own custom authentication service. But we're just going to use Cognito, but you can use Cognito, you don't have to use Cognito, and you can use all of these. You can have login with Cognito, Amazon, Facebook, the whole lot of them if you wanted to. So it's quite a powerful service from that perspective. So the first thing we need to do is put that user pool ID. So we need to go back into the user pool. So we need to go back into services and then back into the Cognito main console. If I can find it, there it is. Okay, manage your user pools, and we'll get that user pool ID, which is this one here. So we want the pool ID, we don't want the ARN. And we put that in there. We also need to grab that client ID of our application. So we just go into app clients and we'll grab that client ID. We'll just copy that over. And that's all we need to do. So that app client ID and user pool ID, they're all different, and the identity ID will be created after this. So let's go and click on create pool. Okay, so what's happening now is that we're now going to be going to the IAM service, because Cognito or Cognito ID needs to have permission to access resources on your behalf. So we do that obviously for a service through an IAM role. Now we have two roles here. We have one for the authenticated identities and another one for the unauthenticated identities. So I'm just going to keep that. Let's have a look at the policy name first. So we're not even allowing unauthenticated, so it doesn't really matter. I'm just going to just get rid of that. Change it to a different name so it won't give me an error. And I've already used this role, so I'm just going to change this one to a different name as well. Now we need to view this policy document. So just edit. It's going to come up with a little warning saying, well, better read the documentation before you play with this. That's fine. Just expand that out a bit. So what we've got there is a policy that allows whatever service that assumes this role, it allows to have access to mobile analytics for put events, to the Cognito Sync service and Cognito Identity service. We want more than that because we want these temporary credentials to be able to access Amazon S3 as well. So we're going to add that to that. So just going to copy that over from the lab notes. Okay, so I've just copied and pasted that in there. So you can see here we've got the same permission that we had before. We haven't changed that, but we've added an S3 service in here. So we're allowing for, we've got two allows here. The first one is to list buckets. in a folder within our main bucket. So you need to change this to the name of your bucket. So this one here is backspace lab pcoder. You need to change that to the name of your bucket that you just created. And what it does, it allows to list buckets within a folder called Cognito and then a subfolder of that called backspace-academy. We have another one here that has get, put and delete of objects within that bucket, and then another subfolder of that called Cognito, and then another one called Backspace Academy, and then another folder or subfolder of that, which is going to be in the name of that Cognito user, or that Cognito user's ID. And so what that means is that that person can upload or delete or change objects, but they can only do that in a folder that is specifically in their Cognito ID, and they cannot access any other part for delete or put or anything else on that bucket. So we'll just click on allow, and that's all successful, and it brings us back into here with some sample code. So this is for Android. We can have a look at the JavaScript code. It just tells you how to create AWS credentials, which is what we've got there. That's not going to be enough for a user to access, but we'll go into that later on. But what we need to take note of here is this user pool ID, and that's what we use to access, or what we use as with our authenticated service to access our temporary credentials. So I'm just going to go to the dashboard, and there we can see that we have a dashboard that shows how many identities are logging in and what are the authentication methods. So here we've got that user pool, but we might have here a Facebook authentication method and Google or whatever. So those will be listed up here, and how often they're being accessed through those different methods. So now that we've done that, we can look at getting stuck into creating our web application that has this Cognito power behind it.
Welcome back to Backspace Academy. Here we are at the stage now where we're going to be creating some code to interact with Cognito. So what I've got here is I've got the code for the application on my desktop, and I've just opened it up and we'll just have a quick look at it. And what we're going to be doing is modifying it and then uploading it to that Amazon S3 bucket, and then refreshing our browser memory and then our browser cache, and then we'll have a look and see what happens. So first thing we want to have a look at is this index.html. So we're not going to be touching that in any way, shape or form. It's really just a user interface, just some buttons and whatever. But what we need to know here is at the bottom of the page, we've got our AWS software development kits. So the first one there is the Amazon Cognito Identity JavaScript SDK. And that will load first, and then after that we're going to load the AWS JavaScript SDK. And then once they've all loaded, then we're going to start our application. Now when this application first starts up, the buttons won't be shown. What will be shown will be a spinner image, and we need to have that spinner image there and not the buttons, because we need to make sure that we don't click on any buttons or get any code running until our JavaScript SDKs have loaded in. And then once that happens, the spinner icon will be disabled and the buttons will be enabled. So let's have a look at how that works. So we just jump into app.js, and so we've got a self-invoking anonymous function. So when this invokes, it's going to, first thing is going to hide that spinner, because we've just loaded up our JavaScript SDK and now we're at this stage. And then it's just going to show those buttons that need to be shown. So that's what you need to include in that feature within your application to make sure that there is no code going to be running until that JavaScript SDK is loaded in. Then what we've got is we've got some click event listeners for those buttons that are just going to refer us straight off to some functions. So if we click the sign up button, it's going to take us to the sign up function there. So pretty straightforward stuff. And here we have those functions. So nothing too unusual there. Now, as I said before, we've got this app-final, which is the final code for the application. So this will be running code. You can use this, not a problem. And this is what we're going to develop. But if you're going to use it, there's obviously a lot of things that you need to change in here. Obviously, user pool ID, client ID, all that sort of stuff. So what I'm going to do is just start off with, in our main code, there are a number of variables that need to be accessible within this self-invoking anonymous function. First one being is a region. We need to configure the region. We're using US East 1 for this lab. Make sure that you are as well. We need to have our user pool data, so we need to have that user pool ID and the client ID for our application. We also need to have the identity pool ID from the identity pool that we created. We also need to define a database name for our key store database that we're using with Cognito Sync. And we're going to have some variables there to hold information on our Cognito user, our identity ID, and the Cognito Sync database. So I'm just going to copy those over now. Okay, so let's have a look at the sign up function first. So I'll just copy that over now. Okay, so there are a number of things that we need to collect off our user in that user form. So the first thing we need to get off them is their username and password that they would like to use. And then we need to collect these attributes. Now, if you remember from when we created the user pool, we selected some attributes that we wanted to collect from our user upon registration. And they were the given name, the family name, email address, preferred username, website, gender, birth date, but we also added a custom one there for LinkedIn. So the way we define those is custom : and then the name of that custom that custom attribute. And then what we need to do is we need to pass them over as parameters to the Cognito service with our client ID for that application with that user pool and the password username and then those user attributes. So what we do is we create a Cognito Identity Service Provider object and we use the sign up of that and we pass the parameters to that. One of three things will occur. We'll get an error, hopefully not. And the kind of errors that could happen is that if we've already signed someone up and they go to sign up again, then that will come up with an error. If we're trying to use a username or email that has already been used, that will come up with an error. But if everything goes fine, we won't get an error, and then another two things will happen. If we've set up our user pool to actually have a verification of our email. So what will happen is the person will sign up and then they will get sent an email to verify their email address. And we've actually done that with this user pool. When we created it, we did actually say that we wanted to have verified emails. So when this person signs up, the user confirmed flag of the data will be false. And so what we need to do is we need to send a message to that user to tell them to go and check their email for that verification link. And if we look at the user pool of that person, it will show it as being unconfirmed. And then when they click on that verification link and then we go back into our user pool and have a look at it in the console, we'll see that that user will be confirmed. If we didn't decide to have email verification and we just said that, just sign people up and don't bother about verifying their email, then that data.userConfirmed would be true, not false. So what we'll do now is, actually before we do anything, I just want to point out here that we're actually using AWS JavaScript SDK. Now the reason I'm using that rather than the Cognito JavaScript SDK is that it has better functionality or better reporting back of errors when something goes wrong. So in a situation like this where you don't have, or where you have verifications of email and that person will be unconfirmed, what the Cognito JavaScript, it will send an error message back with nothing else, just a 200 response with an error message, and you won't know what's going on, and that's pretty poor. But when you use the AWS SDK, you get more information back. It will come back with this data saying whether the user is confirmed or unconfirmed. So and it won't come back as an error, but it will come back as an error with the Cognito JavaScript SDK. So if you're wondering why I'm not using the Cognito JavaScript SDK for this part of it, that is why, and it's going to make life a lot more easy for you. Now, before we do anything, we need to make sure that we put the correct information in here for our user pool ID. So I'm just going to go back into our AWS console, and so we've got our general settings here for our user pool. So there is our user pool ID. I'm just going to copy that and bring that over. And our client ID, so we go back to our user pool, we select app clients, and there's our app client ID, so we'll copy that and bring that over as well. And we need our identity pool ID, so we need to go into our federated identities. This is our federated identity pool here, and we just need to get the details of that, so we can just go to the sample code here and select JavaScript, and that will give us our identity pool ID that we need to use. So we just copy that one from the sample code and we'll put that into our application as well. So there we have our identity pool ID. I'll just put that in there, and I'll leave backspace -users. I'll use that. That's okay for a name for a database, not a problem. So we'll save that. Now that that's all done and ready to go, we can upload it to our bucket and run our website and see what happens. So jumping into the S3 console, we can upload our new app. So we go to our bucket first, and then we select our JS folder, and we'll upload our new app.js to that, making sure that we have public permissions on that, and upload that. Next thing we need to make sure is that we clear our browser cache. So I'm just clearing the data in my cache, and once we've done that, we can go and refresh our website. So you can see there the spinner is showing while the JavaScript SDK is loading, and then after some time that will stop. So obviously if you're going to have a home page, you wouldn't have this happening on your home page every time someone goes to it. So you'd have a landing page, and then you'd have a sign up page that would do this, because you're not going to need this, unless someone's signed in or signing in. Okay, so we've got our buttons there available, so let's go through the sign up process. So we'll put in all our details. Okay, so thanks to the magic of pre-recorded video, I've very quickly put that in there. So we've got our email address there, we've got our password, all of those attributes. We've also got our custom attribute in there, which is our LinkedIn profile page. We'll click on, actually what I'll do first is I'll press F12 so we can see anything that's coming through on our console. And I'll just click on sign up and see what happens. So we're starting the sign up process, user confirmed. And let's have a look at that. So we've got here user confirmed is false. So remember when we're saying that this will come back as false if you still need to click on a verification link. If we didn't have that happening, then this user confirmed here would come up as true. And so because of that, our code has picked up on that, rather than using the Cognito JavaScript SDK, which would just give us an error, which I think is absolutely crazy. Using the AWS SDK, we can quite safely handle this and get our verification link. So we just click on OK, and that's all we need to do. So what we do now is we go into our email and click on that verification link, and then that will change. So what we'll do is, before we do that, I'm going to jump into the user pool and have a look at our users and groups. So it's saying there no users found, but there are. So what we need to do is just click on the refresh button here on the right hand side. Click on that, and there we can see, so there is that user. It's enabled, but the status is unconfirmed because I haven't clicked on that email verification link, which I'll do now. Okay, so I've just clicked on that verification link and it says that my registration has been confirmed. So I'm just going to close that, go back to my user pool, and I'm going to click again that refresh icon and see what happens. And there we can see that the status is now confirmed. Okay, so the next thing we need to do is to go through a sign in process. So let's have a look at that. Okay, so back in the Atom IDE, we'll have a look at this sign in process. So what we've got to do, it's going to have two components to it. It will have a sign in using the Cognito JavaScript SDK. And once we've done that process, we will receive a JSON web token or JWT file from the Cognito Identity Service. We can use that Cognito token or that JWT token. We can pass that over to the AWS JavaScript SDK, and that can create federated credentials for us to access other AWS services such as Amazon S3 if we have defined a role that allows that to happen, which we will be doing. Now, so first of all, I'll just jump into that app final and copy the sign-in process first and put that in here. Okay, so let's have a look at that. So first thing we need to do is we need to collect that information, being the username and password, from the form on the user interface. Then we need to create a authentication details object and put that authentication data inside of it. Then we need to define our user pool, and that will be the pool data, which we do in a Cognito user pool object. And then we create user data, which will be a combination of the username and our user pool. And then what we also do is that we then create a Cognito user or a Cognito user object with that user data. Then once we've got all that done and we've got all that information in that Cognito user object, we can then call authenticate user and pass the authentication details to that. Now, one of three things will happen. So we will get a success and everything is fine, and we will receive our our JSON web token, which we can then use to pass over to the JavaScript SDK to get our federated credentials. If that doesn't occur and we get an error, it doesn't always mean that everything went wrong. It might just be something minor that is not perfect, that hasn't got you the full success and given you your JWT token back. So if you get a 200 message back, that means that you have signed in, but there is some minor issue at stake there. So what you need to do is then, if you get that error message of 200, then you need to call userpool.get current user. Now, if that's null, it means that that person is not signed in. If it is, then you are signed into Cognito successfully, and that process has actually worked. So then what you need to do is to call the create credentials function that we're just about to make, and we need to pass that JSON web token over to the AWS JavaScript SDK to create those federated credentials. So let's now create this create credentials function. Okay, so now that we've got our JWT token from the Cognito ID service, we can now pass that over to the AWS JavaScript SDK. So we do that with AWS config.credentials. We create a new object and we'll pass that identity pool ID, and then we'll pass the login information, which will be a URL there followed by our user pool ID. So what we need to do is go back into our user pool, not our ID pool, our user pool. Click on general settings and we'll get our pool ID up here. We just copy that over and we'll put that in there. And so then all we need to do is pass, with that user ID, pass our ID token, which we got, our JWT token, and that is enough information for AWS to create those federated credentials for us. But just because we've created this object here doesn't mean that we now have credentials available to use. We need to actually now refresh those credentials. So we do AWS config.credentials.refresh, and if everything is fine, then we'll get a message saying we have successfully logged in, or we are now signed in. And then we have credentials available for us that we can use to access other AWS services. So let's have a look at that. We'll just save that now, and we'll jump back into S3, and again we'll upload the new app.js. We'll make sure that we have public access on that object, upload that, and we'll make sure that we clear our browser cache. So clear all our browser data, and then we can go back to our website, we can refresh that and see what happens. So again, we're downloading the JavaScript SDK. Okay, so we will sign in first and see what happens. So we'll just we can use either our username or our email, but that will be fine. I'll just use the username now. I think that was the password I used, or hopefully it is. I'll just click on F12 to see what's happening. Okay, so I got an error message there saying incorrect username or password. So I just must have used the wrong password. So I'll just try it again, sign in. I'll try that. Okay, so that one worked. Okay, make sure you don't forget your password like I just did then. So we got there in the end, so you are now signed in. So signed in successfully and successfully logged in. So that all worked. So we are now signed into the Cognito service, and we are also signed in and have federated credentials to AWS config. So what we need to do now is to implement a sign out process. So let's see how that works. Okay, so now back in the Atom ID, let's have a look at this sign out function. So again, I'll just copy it over from the final. Okay, let's have a look and see what's going on here. So the first thing we need to do is that we need to check whether or not we actually have someone signed in on that device. Otherwise it doesn't make much point in doing a sign out. So first thing we can do is we can see whether there is a valid Cognito user that is signed in. If there is, that's fine. Otherwise we'll just send a message and safely get out of that function. Now we need to ask our user a question, because there are two types of sign out process. So we can sign out locally on that device and invalidate that token for that device, or we can sign out across all devices, and that will require the Cognito service to invalidate all tokens that have been issued for that user across all devices. So there's two options there. You may just want to just sign out locally if you don't want to ask this question, or you may want to sign out globally for more security for the user or whatever. It's up to you, but I've just basically got the two options there for you, and you can make the decision yourself in your own applications. So if you decide to, or the user decides to sign out across all devices, then that will call the global sign out function of Cognito user. And if they decide to just sign out locally, then that is the sign out. Now there is a callback on the global sign out, and there will be an error if there's an error there, but we don't have that function with the normal sign out. There's no callback function on that sign out as such. But with global sign out there will be an on success or on failure callback there. So we'll just save that and we'll upload it again to Amazon S3. And again, make sure that we've got public permissions on that object. Upload it, and we'll clear our browser cache. And then we'll refresh our application. Okay, so we'll just sign in. Okay, so we're successfully signed in. So let's try the sign out method. Okay, do we want to also invalidate all user data on all? We might as well, because that seems to be the most complicated of the options. Okay, successfully signed out and invalidated all app records. Wonderful. So our sign out has been implemented quite good. Now, what if our user wants to change some of the details in their profile? So we'll look at the update profile application section now. Okay, back in the Atom IDE again, I'm just going to copy over the update profile function and put that in there, and let's have a look at it. So the first thing that we need to do is make sure that we have someone logged in. If not, then we safely exit the function. So if Cognito user is null, then we just send a message saying that there's actually no one signed in. Now then we actually have to get the attributes from a form, and that form will be similar to the registration form, but it'll only have the attributes on there of given name, family name, website, gender, birth date, and the custom one there for LinkedIn. Once we've got that, then we can add those to a Cognito user attribute one by one. And then what we do is we push them out to the attribute list. So we create a Cognito user attribute, and then we create an array of those by pushing those through one by one after we've created that Cognito user attribute. Okay, so once we've got that attribute list, then we can pass that over to update attributes, which is again a function of the Cognito JavaScript SDK. Once we've done that, we've got a callback, and it'll either give an error or not. And if it's successful, we just do an alert out there saying successfully updated. So we'll just save that, and we'll upload that and see how we go. And again, public permissions. And again, we clear our browser cache, and we refresh our application. Okay, we'll sign in. Okay, signed in. Okay, let's update that profile. So I'll leave that the same. Maybe change the website to whatever. That'll do. Yeah, whatever.com, that'll do. Okay, let's update that. Successfully updated. Wonderful. I'm just going to press F12 and see what happened on the console. So what we got was a cool result is success. That's all that's returned from that. So that's pretty good. Okay, next thing we need to do is to start using our credentials that we've got from Cognito to start using the Cognito Sync database. And what that will enable us to do is to store more information on our user for this application in the form of a key and value. So let's have a look at that. Okay, before we get into Cognito Sync, there's just one more function that we need to sort out with our sign up process, and that is if the user has forgotten their password, which happens quite often, we all know. So again, we'll just copy that over from the final and put that into here. Let's have a look at it. So what we've got is that the first thing that happens is that we need to create a user pool with that user pool data, and we also need to get from the user their username or email, and then we can put that in user data, being the username and the pool, which is the user pool ID. So then once we've got that information, we can then create another Cognito user object. Now we don't use Cognito user, well, there won't be a Cognito user as yet because this user has not signed in. So we need to create a Cognito user object using the JavaScript SDK, and then once that, then we can run the forgot password function of the Cognito user. So we will have an on success callback or an on failure callback, but optionally in there we can have a input verification code callback. So what that enables us to do is that not only do we start the process of forgot password where it sends out a verification code via email, we can also have it so that when this function occurs, that it actually asks for that code to be inputted in, and then we can input, or the user can input that code, and then they can put in their new password. If we don't do it that way, then we need to actually have a second button there for inputting the verification code. So this is a lot cleaner that we do it all in one function and with one call to the Cognito JavaScript SDK as well. So what we got there is that the input verification code will come back with a callback, and it will ask for that input verification code, and we will pass that over to the Cognito user confirm password. So if we didn't have that in here, in this part of the callback, we would have to have this as a separate button where you would say, confirm your new password or whatever, and we would call confirm password and pass that verification code in there, and along with our new password. And then again, we'll have an on success callback or a failure callback. So that's how that works. It's quite a bit involved in that, but it works quite well. So we'll save that and we'll upload that again to our bucket. And again, make sure that we've got public access to that. And again, we will delete our browser data, and then we can refresh our website. Okay, so we'll sign in. Actually, no, we won't sign in because we've forgotten our password. So let's click on the forgot password link. Enter your username or email. So I'm just going to use my username. That will be fine. Okay, so it's asking for that verification code. So what we need to do is go to our email and put that in there. So I'm just going to grab it from my email and put in a new password. That'll do. Okay, the new password has been confirmed. So that's done. Now we'll just jump back in and start doing our sync database function.
And again, we make sure that we've got public access to that. And again, we make sure that we clear our browser cache, and then we can refresh. Okay, we'll sign in. Okay, I remembered my password this time. That's great. Okay, let's add a sync record to our sync database and see what happens. Okay, let's have a look and see what happened. So we signed in successfully. We've called list records, and it's given our count of records, which is 0, and the sync count is 0. And it's also passed us our sync session token, which is in here. Okay. And here we go. We've got our sync session token and our dataset count that we're passing over to our add record. Okay, and so what we get back here is the record. So I'm just going to copy that over and see what we get back. Just have a look at a JSON editor and see what happens. Okay. Okay, so we've created, so it sends back to us what the record that has been created. So we've created a record with a key user ID, and the value is that user's Cognito identity ID. So it's done exactly what we want it to do. But again, you could create records for whatever, high score, and then the high score value for that user for a game, for example. So that's working quite well. So what we'll do now is that we'll look at using the Amazon S3 service this time with these federated credentials. Let's have a go at that. And again, back in the Atom IDE, let's have a look at creating this object. So I'll just copy the code over and place that in there. Okay, now what we're going to do is that we're going to use the AWS JavaScript SDK for this. We're not going to use any of the Cognito stuff. And we're going to create a new S3 object, and then we're going to call put object and put an object into a location on a bucket. So what we need to pass to S3 is we need to pass the bucket name, and then to put that object we need to put in these object parameters. So those object parameters are going to be the bucket name, which will be \lab-b Cody. It will be different for you, of course, because S3 bucket names are unique. Then we need to put in a key. Now what a key is simply the location and name of that, or the path to that object when it is uploaded. So what we've got here is it's going to be incognito \academy, and then the identity ID of that Cognito user, and then it's going to be called test.json. Now if you remember from our role that we created, we do have access to Cognito \academy and a folder which is in the name or in the identity ID of that user. So that role will allow us to do that. So we've got that, we've got our object parameters there. Our content type is going to be a JSON file, and the body will be simply an object called test with a key test, and we're just going to say it works. So it's going to be a JSON object there, and we just need to JSON stringify that data before we send it over to S3, and that's what we do there, and that will be the body of our object that's uploaded. So what we'll find when we upload it, we'll find in that directory Cognito \academy and then the identity ID, we're going to have a file called test.json, and inside that file will just be a simple test it worked key and value there. So when we pass those object parameters to S3 put object, we'll either get an error or we're going to get a success call there. So that's all there is to it. I'll just save that and we'll upload that to Amazon S3. And again, we make sure that we have public access to that. And again, we make sure that we clear our browser cache and then refresh our application. Okay, so let's create an S3 object. Okay, so that worked fine. We've got the success callback. Let's have a look and see what happened in the console. So what's happened here is we've got our test.json has gone to that location in our bucket. So let's have a look at the bucket and see what happened. Just refresh the screen here. Okay, so now we have, which we didn't have before, we have a Cognito folder. And let's have a look inside that. We've got a \academy there, and we've got another folder in the identity ID of the logged in user. So let's have a look at that, and we've actually got a test.json. Let's click on that, and let's download it and see what it looks like. Okay, so there we can see we've uploaded a JSON file and it's come out as test for a key, and it worked, which is exactly what we wanted. But of course you can do something more with that. You might want to have, create the next Dropbox or whatever and have it so that users can upload files and whatever they want to do. So it's all up to you what you want to do with these user credentials. Okay, so that brings us to the end of all of that Cognito stuff. What I'm going to do now is that when we ran this code, you notice that it took a long time for the JavaScript SDK to come in, and that's not something that you really want to do because the JavaScript SDK is quite big. It has all of the SDKs for all of the services for AWS, so it's a really good idea to really cull that down as much as possible. Now what I'm going to do is show you how to techniques that we can use to make this load a lot quicker. So if you're a React.js user or developer, you're probably quite familiar with Webpack. I use that quite a bit myself. So you can use that to really cull down the size of the JavaScript SDK. But I'll show you another way that AWS has where you can actually build your own version of the AWS JavaScript SDK that will only have the functionality that you require. Okay, so now that we've finished with our lab, we can clean up those resources. So we need to work backwards like we normally would. So we start off with our federated identity, our identity pool. We need to remove that first. So what we do is we go to the dashboard, and then we click on Edit Identity Pool, and then we scroll down to Delete Identity Pool, and then delete that identity pool. And that's all we have to do for the identity pool, quite straightforward. With the user pool, there's a few things that we need to do first. So we need to go to our domain name and delete that domain, which is done. And then once we've done that, we can go to our general settings again and delete that pool. And we just need to type in delete and delete that pool. Okay, so that's how easy it is to do that. And of course, we go into our S3 bucket and we can delete our bucket as well. So we select our bucket and delete that bucket. Oh, I better just copy the name of it first. Okay. And there goes that. So we've cleaned up everything. Now we'll have a look at some of the ways that we can improve the performance of this JavaScript SDK. Okay, so there are a number of ways that we can reduce the size of the SDK for JavaScript and to increase the performance of our application while it's downloading that. And probably the best way would be to use Webpack or Browserify or whatever you want to use that is going to basically look at the import statements on your React.js app or whatever you're using and basically optimize that for it so that you're only bringing in what you need to bring in. There is another way, and it's specifically for the AWS SDK for JavaScript. It's not for the other SDKs, but just for that one, which is quite important because that is the big one, because it has all of the SDKs for all of the AWS services. So if you're pulling that one in, it's a bit big. So we get to it by going to sdk.amazonaws.com/builder/JS, and there's a link to that in the lab notes. So have a look at that. When we get there, it's going to have some stuff already pre-selected for us. We'll just clear all that for now because all we need is Cognito and S3. So what we can do is just in our browser, just search for Cognito. And there we go, we've got the Cognito identity pools that we need to access. We have the AWS Cognito service being our user pools that we need to access as well, and the sync database as well, Cognito sync key store. We need to access that. Also, we need to access Amazon S3, and so there is libraries there for Amazon S3 that we can add there too. That is how easy it is to do it this way, and very, very quick and easy. I love it, you know. So we've got here the build configuration. We've got identity, user pools, and sync and S3 there. So we just click on build. After a certain amount of time, it'll build that for us, and there we can see we've got our AWS SDK, which will be the latest stable version of the SDK, which is good. And it will be optimized to include only Cognito and S3 and the basic AWS stuff such as config and all that sort of thing that we need. So that brings us to an end. If you've enjoyed this, make sure you go out there and give it a good rating. And it's been a great lab. You've got a lot of stuff that's going on here, and it's going to be really good to do these sorts of very long and in-depth and intricate labs because it's going to give you the confidence that you need to be able to use these JavaScript SDKs. And if you're going on to become an AWS certified developer, then you're going to have a lot of confidence in using the AWS JavaScript SDK as well. So I've enjoyed it, and I look forward to seeing you in the next lecture.
And welcome back to Backspace Academy. In this lab, we're going to be developing a serverless JavaScript application, and we're going to host that on Amazon S3 and front it with CloudFront. In that application, we're going to be using the login with Amazon Software Development Kit, and that will allow our users of our application to use their Amazon login details to assume a role which will give them temporary AWS credentials. Then we're going to use those temporary credentials to read and write to a DynamoDB table. Okay, starting off in the Amazon S3 console, we want to create a bucket to host our website. So create bucket, we'll give that a name. And next. And next again. So we want to make this public. So grant public read access to this bucket and create bucket. Okay, so in the lab notes, I've got some links to two files, one called index.html being our web page and app.js being our application code. So what we need to do is to download those and then upload these to our bucket. So we'll just click on the bucket now and we'll upload those two files. And next, we need to grant public permissions for this and upload. So once that's finished uploading, we need to enable static website hosting. So go into properties and static website hosting. We'll put that in there, put our index.html and click save. Okay, so now that we've done that, we should be able to go to this website now and just have a look at it, make sure it's all working. So that's working fine. So what our web page simply is, it's going to have three buttons there. One which is a login with Amazon button, a log out button, and then a write to DynamoDB. So once we've finished logging in, we can write data to, or we're going to get the user profile data from the Amazon.com service, and then we're going to write that to a DynamoDB database. To have this running properly, we need to have it served out of HTTPS domain. So obviously we can't do that using static website hosting, but we can if we front that with CloudFront. So we're going to do a CloudFront distribution. So go into CloudFront. And we're just going to use the standard CloudFront certificate as well. So we go create distribution and get started. The origin will be our bucket that we just created. And we want to redirect everything to HTTPS. The reason we need to do this is that the login with Amazon service will only work with a domain that is under HTTPS or SSL. And we're just going to use the standard SSL certificate. And the default root object will be index.html. And we'll create that distribution. Okay, so while that CloudFront distribution is happening, I'm just going to jump into the Amazon.com Seller Central. Now, there's instructions in the lab notes on how to register with Amazon.com as a developer. So you need to go through that registration process. Once you've done that and you've logged in as a developer on Amazon.com, you'll be presented with this screen here. So what we need to do is that we need to register our application with Amazon. And once we've done that and we've given all the details of the domain name and all of that sort of thing, what we will get is an application ID, and we'll also get a web client ID. And we need both of those IDs. One of them goes to Amazon. Goes to Amazon Web Services, which is the application ID, and the other one goes on our web page, which will be the client ID. So to start with, we go to register new application. We'll give our application a name. And we'll give it a description. And we need to put in a privacy notice URL as well. So I've just got one here that I've just copied off the internet. It's just a sample one. And I'm just going to put that in there, which I've uploaded already to an S3 bucket. And I'm just going to say, put in a logo as well. I might as well put in a logo. Why not? And we'll save that. Okay, so that's done that part of it. So what we need to do now is put in the web settings, and that's going to give them, or give Amazon, the settings of our application that we'll be running. So it's going to be a web application for starters. It's not going to be an Android app or an iOS app. So we click on web settings, and what we need to do is edit that. And we need to put our origin of our domain. So that's going to be our CloudFront domain. So we go back into the CloudFront Manager. We'll copy that domain. Okay, so it needs to have the HTTPS : / in there as well. And the last bit of it will be cloudfront.net. So that's all you need to do for that, and save. Okay, so you've now got your client ID and you've got your application ID that you need to go further. So we'll just jump back now into the CloudFront and see how that's going. Okay, so CloudFront has finished creating that distribution. So we'll just jump in here and have a look and see if it's working. So that's fine. So we've got that up and running on CloudFront, not a problem. So what we'll do now is move on to the next step, which is creating our DynamoDB table. So go to Services and DynamoDB. And we want to create a table. And we'll call it Login with Amazon Test. Now, use the same table name as I've got here because the code is actually around this table name. Otherwise, you'll have to go into the code and change it. So our primary key, again, leave this the same as what I've got in the lab notes, which is just customer with a capital C. So just remember it is case sensitive, so make sure that customer is a capital C there. We're not going to use the default settings because I want to save a bit of money. So what I'm going to do is turn off auto scaling because we really only need one read capacity unit. And we'll just change that to the minimum and save a bit of cost. So if we forget to delete this, it's only going to cost us 60 cents a month, so not a problem. And we create that table. And that's now been created. After a certain amount of time, it will be ready to go. Okay, jumping into tables, and we can see there that is now active. So I'm just going to click on that again. What we need to do now is that we need to create an IAM role that will give our end users, or our end users can assume, that will give them federated temporary access to this table so they can read and write to that table. So we're just going to go to the tab that has access control. We're going to select Login with Amazon, which is what we're using. We'll select all of the actions there and we'll create this policy. So there it has automatically created that policy for us, which has saved us a lot of time, means that we don't get many mistakes in here. So all we need to do now is to copy that policy over to IAM, and then we can create an IAM role using that policy. So the first thing we need to do is just copy all of that. So Control A and Control C, or Command A, Command C if you're on Mac. And we'll go to the IAM console now. And we go to roles. Actually, first of all, we'll go to policies and we'll create a policy and we'll paste in, we'll delete what's in there now and we'll paste in our JSON code in there. So let's have a look at it. So what we've got is we're allowing all of the actions there on DynamoDB, and it's going to be on our login with Amazon test database, or sorry, our test table. And it's only going to be, it's a condition against it. So it's only going to be allowed where the leading keys have user ID. So what that means is that our primary key of our database is customer. And so where the customer has the value of our Amazon account, or the user's Amazon account, they can write to that, but they can't write to anything else. So it's limited to entries on their own account. So just click on Review Policy. We'll give that a name. And we'll give it a description as well. Okay, so there we can see it's got limited read and write access, and on the resource, log in with Amazon test, that table, and it's only going to be where the leading keys or the partition, which is customer, where the customer equals the Amazon.com user ID that has been logged in. So we just create that policy now. Okay, so that's been created now. So now we can create a role using that policy. So create role, and we want to do web identity. Our identity provider will be login with Amazon, and our application ID. So we need to get this application ID from Amazon.com, from our developer account. So we go back into our developer account, and we can see up the top here, we've got our application ID. So we've got two IDs. We've got an application ID and we've got a client ID. So for this part of the process, we use the application ID. So we're just going to select all of that and copy that over. And go to permissions. Now this is where we search for our policy. So I'm just going to do login. You should find it. So there's our policy that we just created. And we review. We'll give this role a name. We'll just call it login with Amazon DynamoDB. Again, that will be fine. And a description in there. And that looks fine. So we've got our policy there, which is our login with Amazon DynamoDB policy. We've got our identity provider is Amazon.com. And we just click on create role. Okay, so that role has now been created. So if we click up here to that role, to get to that role, we can see here we've got a role ARN. So we're going to need that later on in our code. And what we'll do is we'll jump into our code and we'll put that in there now. So just copying that now. And I'm just going to jump into my app.js code that we uploaded. And we can see here we have a variable role ARN. So we need to put our ARN for our role into there. So that's done. And what I'm going to do now is I'm going to save that as a different name. And I'm going to call it app underscore version 2. Now, the reason I'm doing that is because we've got a CloudFront distribution. And so if we're going to just keep using app.js and we upload app.js, we're going to have to invalidate that CloudFront distribution, which is going to take a long time. You know, I haven't actually measured it, but you're probably looking at half an hour or so to invalidate that CloudFront distribution. So instead of doing that, we just need to upload a new file. And this is what that is. And so if it's not in the distribution, it will just get proxied straight back to Amazon S3 and it'll go from there. So we'll just save that as version 2. I'll just copy the name first and save that. And I need to go into index.html and scroll down to here because this is referencing app.js. So we need to put the new file name, which will be app version 2.js. And we also, if you see here, we need to put in our client ID. So if we go back into the Amazon.com Seller Central, if we scroll down here in our web settings, we're going to have a client ID. So we select that. So don't get this confused with the application ID that we used before. This is a client ID. And we'll put that in here. Okay, so that should be fine to run. So what I'm going to do now is I'm going to file save that as another version as well. And save. So all we need to do now is upload that and run our application. So we go into the S3 Management Console and upload that. And again, make sure that we've got public permissions on this. and upload that. Now, before we run this application, let's have a quick look and see how it all works. So in our index.html, or version 2 that we've got here, we can see it's just a blank, pretty well a blank canvas here, which has just got some buttons on it. So we start off by loading the Amazon, or the login with Amazon JavaScript SDK. And when it has been loaded, we then pass our client ID to the software development kit. Now, that is going to be our web client ID. If this was an Android app, it would be our Android client ID, or it would be our, if it was an iOS app, it would be our iOS client ID there. So because it's a web application, we're sending our web client ID to that. So once that has been loaded, we've also got here some buttons for login and for logout and writing to the database. We're just loading jQuery and the Amazon, or the AWS software development kit. And then finally, we're loading in our app.js, or app version 2 here, JS code. So let's have a look. So not much going on there other than loading in our login for Amazon JavaScript SDK. So if we go to our app, there's a lot more going on there. So first of all, we've got to define our region as US East. We've also got a variable there for our role, ARN, which will be passing to the AWS simple token service, or secure token service. And we've got our event listeners for those 3 buttons, being our login with Amazon, which will go to a login with Amazon function, which is down here. If we want to log out, it's going to call the login function within the Amazon SDK. And finally, we can write to DynamoDB using a write DynamoDB function, which we're creating as well. So when we log in and we click on that login function, the first thing, or login button, the first thing we want to do is define the scope of our call to Amazon.com. And that will be to retrieve the profile. And that will be the email address and the name of our end user. So what we need to do is that we need to run the authorize process. And if that is successful, it will open up a pop-up screen or pop-up window. And we put in our Amazon.com username and password to that. If it's accepted, then we will get a good response back, an okay response, not an error. And in that response, we will get an access token from Amazon.com. So we can use that access token that we get from Amazon.com for 2 things. First of all, we can go back to the login with Amazon service and we can retrieve the user profile information for the person that has just logged in. And so that again will get us our name and email address of that person. So that's what we're doing here, is that we're calling retrieve profile and we're passing that access token there. And in our response, we're going to get the user profile of that person. So if that is successful, then we go on to create our AWS credentials. So that will, again, it will be similar to what we do with Cognito, but instead of using the Cognito service, we're going to be using web identity credentials. And what we do is we pass the provider, which will be Amazon.com, the ARN for our IAM role, and finally, we're going to pass that access token that we got from login with Amazon. So once we've created that object, we can refresh our AWS credentials and we'll reload that in. And so if that is successful, then we're going to create a DynamoDB object that we can use for calling to the DynamoDB service. So when we click on that write DynamoDB button, what it's going to do is it's going to write to DynamoDB the user profile information, and it's also going to put in the top score information for that user. So how does that work? So we're going to define some parameters for our item that we're writing, and it's going to be customer, which if you remember, when we created our DynamoDB table, customer was the primary key for that table. And if you remember when we created our role, the access had a condition that the primary key, being customer, must have been the same as the user that is logging in their Amazon.com ID. So what we're doing is that we're supplying the Amazon.com ID to customer in that item. So that will be accepted by AWS. We're also putting in the email address for the person and the name of the person, and we're putting in some top score information. So I'm just putting in 0 there. But if this was a real thing, you would put in the top score information for their game or whatever they're doing. And once we've done that, we can call put item, and if that is okay, it will just stringify that out and put it out to the console on our screen. So that's how it all works, and what we'll do now is that we'll go ahead and run that. So jumping back in the CloudFront Manager, let's have a look at our new website. So we go to here. Now this is going to be the index.html, so we don't want this one. This is the old one. We want to go to the new one, which will be our version 2, which is there. So what's happened now is that because it's not in our CloudFront distribution, CloudFront has just proxied that straight back to Amazon S3, and we've got that up and running. If we used index.html, we would have had to invalidate that CloudFront distribution, would have wasted a lot of time. So what we can do now is we'll run this application. I'm just going to press F12 to get the console up and click on Login with Amazon and see what happens. So there we go. So I just put in my password. So it's asking for access to my profile. So by logging into this web application, the web application is going to receive my name and my email address. And so I'm going to allow that. Okay, so we can see here, you are now signed in. So everything has worked fine. So we've got in here, don't worry about this a mismatch or a match is not a function, this uncaught type error. That's just a problem with the login. It's not a problem with our code. So looking here, we've got our Amazon login details. And so what's happened is it's returned an access token. So that's a login with Amazon access token. And we can pass that access token over to the AWS STS service using Web Identity Federation. And what it will do is it will create temporary credentials for us. And so we can see here, we've grabbed that access token and we've got our role here that is being used. And we're calling Assume Web Identity Federation with the access token, and it has successfully created the AWS temporary credentials for us. So what we can do now is, I'm just going to clear the console, is that we should be able to now grab that profile information that we've received, which will have my name and my email address, and we can write that to DynamoDB. So let's have a look at how that goes. So just click on Write to DynamoDB. So there we go. If it worked, it will return consumed capacity. So it's just saying here, the table, and we've consumed one capacity unit. And it's written it with the Amazon account there. So what's happened now is that we should be able to go into DynamoDB, and there should be an entry for this user with that Amazon account under customer. So let's have a look. We'll jump into DynamoDB and we'll click on items. And there we can see we've got customer, which was, as you remember, when we created this table, our primary key was customer. And so whatever is in here is provided it's got the Amazon account for the person that has logged in with those temporary security credentials, they can write to here, but they cannot write to any other place within the database. So here you can see, there's my Amazon account ID, there's my email, there's my name, and we've also written in there top score. So if you wanted to put any further details of that user, you can put that in. So if it's a game and you want to keep track of their top score of the game, that's how you do it. So that's how simple and easy it is to use federated identity. Now, why would you want to do that? Why not just use Cognito? Well, the thing is, Cognito, it costs you money. And you have to pay for that. So you might be a cash-strapped startup and you've got the next best thing, and you know that the people that are using your web application have an Amazon account, or they have a Facebook account or a Google account, and you can use that to authorize them, and it's not going to cost you anything to do that. And so by doing that, then you can also expand quite rapidly. So if your app becomes extremely popular, your application is going to be running on that end user's hardware. It's going to be running on their computer or their mobile phone or whatever. You're not paying for that compute capacity, but all you're paying for is the data, the back end being that DynamoDB database, and they're accessing that directly without any EC2 instances, without anything like that in front of it. They're accessing that directly and doing that extremely securely as well. So that brings us to the end of a pretty good lab, I think. And what we need to do now is to clean it all up. So the first thing we will do is that we will delete this table. So when that's chugging away, we then need to disable this CloudFront distribution. So that will take a while to disable. So once it's disabled, then we can go back in there and we will be able to, this delete will be highlighted, so we can delete it. That'll take about 15 minutes or so. And we just delete this bucket. Okay, so that's all cleaned up, and I look forward to seeing you in the next lab. And welcome back to Backspace Academy. This lab session is for developers, so if you're a solutions architect or looking to be a SysOps administrator, you can skip over this one. DynamoDB is one of my favourite services when I'm choosing a backend for an application. The reason being is that being an abstracted service, it does remove you a lot from the maintenance and management of a database. And also it scales very well, and it also allows you to scale it programmatically as well. If you have a look at the project dynamic DynamoDB, you can see how you can actually programmatically scale DynamoDB, which is really, really good. So in this lab session, we're going to start off by creating a DynamoDB table, because we can't really do anything without that. And then we'll look at importing data into DynamoDB as items. And the way we're going to do that is we're going to use the Node.js software development kit to write an application that will read data in a JSON file and then import that data into a DynamoDB table. This is a pretty useful thing to use, because a lot of times you have a customer that might have their files in CSV files or whatever, and you just want to quickly bring that into DynamoDB, and it's a really good way of doing it. I find that a lot of times it can be a very quick thing to do just to get data in very quickly for a client. Once we've got that data in, we're going to look at the ways that we can query that data in that DynamoDB table. So programming DynamoDB with Node.js, let's get into it. And welcome back to Backspace Academy. In this lab, I'm programming DynamoDB with the Node.js software development kit. We're going to do a similar thing to what we did in the previous lab for solutions architects and SysOps administrators, but instead of using the command line interface, we're going to be using the Node.js software development kit. So as before, we're going to be creating a DynamoDB table using the management console, and we're going to be manually typing in an item into that table using the management console. Then in part 2 of the lab, we'll use the Node.js software development kit to bulk upload items from a JSON file into the DynamoDB table. And then we'll use the Node.js software development kit to also query that table. So the first thing we want to do there is to create a table. So if we don't have any tables, we'll be presented with this welcome screen. So just click on Create Table. And we give the table a name. And we're going to give it a partition key ID, and that's capital I and lowercase d if we don't have it
like that, then we're going to have problems. This is case sensitive, so make sure that you do it right. So capital I and lowercase d, and that will be a number. So we select number. And now we're going to add a index to this, a secondary index. So we uncheck use default settings, and then we can add our index in there. So we'll use product category, and then we'll add a sort key of price. So product category will be a string, and then price will be a number. Okay, so that's created our index there. We've got product category as the partition key, our sort key of price, and our index name will be product category -price -index. So let's just add that on there. And there we can see that's done. And we'll leave our provision capacity the same as what it is. And we'll click on create. And what will happen is our table status here will be saying created, or creating, sorry. And then it will change after a certain amount of time to active when has finished being created. Okay, so just fast forwarding, we've got our table up and running. It is now table status active. So what we're going to do now is we're going to add some items to our table. So just click on the items tab now. And we can see that we've got our ID here. And what we can do here is we can create an item. So we're going to give the ID 101. And the product category will be book. And the price will be 2. And now we'll just append another field to this item. So we just click on the plus sign here after price, and we just append, which means put it at the end or put an entry after this. If we used insert, we'll put it before it, or we could actually remove it if we make a mistake. So we're going to append, and it's going to be a string, and this is going to be title. So title of the book, and the book title will be Book 101 title. And so we just go through and we do the rest of those entries as are detailed in the lab notes for this, or in the hands-on notes for this. Okay, and just fast forwarding there, I've entered all the fields there for the items. We've got ID 101, a number, or down to ISBN, which is a string with that there. So now we can create that item or save that item, and there it is for us. Now that process of creating an item using the management console was very time consuming. So we've got hundreds of items to bring into our database. It's not going to be practical, obviously. So in part 2 of the lab, we're going to be using the Node.js development kit or software development kit to bulk upload from a JSON file the items. And we'll also look at using it to query our data to get information that we need. So I'll see you in the next part of this lab.
And welcome back to part 2 of programming DynamoDB using the AWS Node.js software development kit. Okay, so we just jump into our Atom IDE, and what we're going to do is connect up into our Node.js EC2 instance. So if you haven't already created that, go back to the introduction lab where we introduced you to setting up a Node.js development environment using EC2. So go back to that if you haven't already done it. So I'll assume that you have. And what we do now is we just go into Packages, Remote Edit, and we browse our hosts, and we select our host from the list. So once we've connected in, we'll select our index.js file. Okay, select that index.js. So what you'll need to do now is to grab all this, delete it all, and put the code that is in the lab notes. So this code is actually correct now because I've already done this before. So we'll just go through this. Obviously require the software development kit, so that's a require command there. So very important here, don't hard code your credentials. Yeah, we've created an IAM role, so there is absolutely no need to put your credentials. So those credentials you just should not need to use anywhere at all. So you guard them with your life and use IAM roles instead. Configured our region next, and now we're going to create a AWS DynamoDB object, and we're going to issue a command list tables, which will list all the tables in our DynamoDB database, and will console log those out for us. So we've only really got one table, the test table, so we should just see one table printed out on our console. So once we've done that, we can do Control S and upload that. Just to save it and upload it back to our EC2 server. And then we can connect into our EC2 server using PuTTY, and which is where we'll go now. Okay, so we're just now in PuTTY, so we'll just connect into our EC2 instance. Okay, so we're in there, so we'll just navigate to our application. Okay, and we'll just run our node command on that, on index.js. Okay, so what it's done, it's just it's run our application and it's printed out a list of our tables, and there's only one there, test table, so that's working fine. Okay, now so jumping into back into the Atom IDE, so we're just going to now look at creating a function to download data, to download our JSON file, and there's a link to that JSON file in the lab notes, so download that, and then grab that file and put it onto an AWS S3 bucket. This is our bucket name that we've used. Yours will obviously be different to that, and then just create a folder within that bucket called lab-data, and then put the test table items JSON file in there. So what we're basically doing here is we're creating that that function there that's going to be called in the callback for this DB list table. So once that's done, it'll go through and download the data. So we're going to create a new AWS S3 object here. So we created a DynamoDB one up here. So now we're creating an S3 one. We're going to access the S3 service. The parameters we need are the bucket and the key to access that object from the S3 bucket. So S3 get object, pass those parameters in. If there's an error, you just console log that out. If not, we pass that data from JSON to a JavaScript object, and then we console log out that data to the screen. So first of all, we'll have a look at that actual file that we're getting. So here it is here. So what it basically is that we've got a definition here of the table that we're looking for, and then we've got a number of requests here. So put requests against an item with an ID of that, and then we're going to be adding these items too. So that's pretty well straightforward. Then another put to add an item in there with those attributes, and then we go through like that. So here you can see we've got quite a few there all lined up, all ready to go. So you might say that that's quite difficult to do, and it probably would be. But what you can do with this to make life a lot easier is you can actually create this in an Excel worksheet. So if you've got your data there, you can actually concatenate all of the cells together. So you can create this as being one cell here up to where the data is. And then you can put your data in another cell and then create another cell after it, and then just do a concatenate function on that data, and your Excel worksheet, you can just then cut and copy that, cut and paste that into a JSON editor, and it'll format that nicely for you. So we'll just have a look at how this looks like in a JSON editor anyway. Okay, so we just cut that in there, paste that in there, sorry. Transfer it across here. So we can see here we've got our test table main object there, and we've got our entries that we're going input request, item, and that's it all there. So that's how it looks, pretty straightforward. So again, we can create all this nicely in an Excel worksheet and just use the concatenate command to put that in, and then just cut and paste them over, not a problem. Okay, so what we'll do is go back into the Atom IDE, and we'll Control S to upload that back to our EC2 server. And once that's done, we will jump back into our node, our putty command prompt. Okay, so that's done, and then we'll run our node index.js. Okay, so we've successfully connected to the AWS S3 service this time, and we've downloaded that file, that JSON file, and we've output it to the screen, so that's fine. So the next thing we want to do is to actually grab this data and process it and put it into items in our DynamoDB test table. So back into Atom IDE. Okay, so what we're going to do now is, after we've downloaded that data, in our success callback, we're going to call another function called write DynamoDB, and that's going to grab that JSON data that we've got, and it's going to write it to DynamoDB using a batch write command. So, okay, so what we've got here is the first thing we're going to do is pass some parameters, which will be the request items, being our data.json. And then we're going to do a batch write command. So we're going to pass those parameters, which will just be our list of our items that we want to add. And quite simply, if there's an error, we console log out. Otherwise, we'll console log out that data. So we'll just jump back into putty. Oh no, first of all, we won't jump back into putty. We will do Control S to save this. Okay, saving it and uploading it back to our EC2 server. Okay, so that's looking like it's done. So we now run our node again, our node index.js. Okay, so that actually has worked. So what we're looking for is a unprocessed items, which is basically saying that nothing was unsuccessfully processed. So we've basically added all those items to that. So really what we can do now is go into the DynamoDB console and look at our browse items again. So we've got that one there that we looked at originally, the one that we created manually. So now we can start a new scan, and voila, we've got all those additional ones being added into it. So there's our first one that we created manually, and then with just a click of a button virtually, we've created all these new ones. So this is a really good way of bringing data in. So create your data in a Excel worksheet, and then just build your code up from the concatenate command in Excel, and then you can just cut and paste that into a JSON editor to format it, put it into a file, and then run a batch write command, and you can bring that data in. So it's quite a reasonable way of doing it. It's the way I normally bring in data, not a problem. Okay, so now let's have a look at querying that data. So back into the Atom IDE. Okay, so first thing we want to do is now jump into our write DynamoDB function, and in the success callback for that, we will run a query DynamoDB function. So we're basically chaining through here. So the first thing, we're going through and we're connecting into our DynamoDB. In the success of that, we're going to jump into downloading the data from Amazon S3. When that's successful, we're going to jump into write DynamoDB to write it in there, and then once that's successful, we can query the data once it's gone in there. So query DynamoDB function, so that will pass some parameters. Okay, so this is a little bit more complicated. So we've got the table name, the test table, and then we've got a global secondary index that we're going to be using, which is our product category -price index that we created when in the DynamoDB console. And then we've got key conditions. So what we've got here is our product category, our hash, and price, our range. So for our product category, we're going to look for everything that equals, that is a bike, which is string bike. So we're going to look in the product category and find everything that equals bike. And then we're going to look in the range. And we're going to look for everything that is less than or equal to a number 300. So we're looking for all of the bikes that are less than or equal to a price of 300. So a little bit complicated, and we'll look at using key condition expressions, which are a little bit simpler and a little bit easier to understand, but just want to get you across showing you both of the two techniques for querying using the SDK. So again, we do Control S. We upload that to our EC2 server. Okay, so that's done. So then again, we run our node index.js application. Wonderful. So what it will do, it will output to the console all of the bikes that are above, or that are less than or equal to $300. So this one here, it's a bicycle, it's a bike, not a problem. And it is priced $100. The next one here is priced $200. That's fine. And the next one, the last one, is $300 because it's less than or equal to 300. And that's it. That's fine. So if we go into our into DynamoDB console, we can see that's right. So I didn't select that one. So we've got 1, 2, 3. And there's 2 that we didn't get because they were over $300, and we didn't get these because they were booked. So there should be 3 there, and we've got 1, 2, 3 here as well. So that is fine, so not a problem. So now we'll look at a different way of doing it. So just jump back into the Atom IDE. Okay, so I've just pasted in the new query DynamoDB function, and so that's using a key condition expression. So let's have a look at that. So we've got a table name, test table. Again, we've got our index name, the same as before, our global secondary index there. But what we've got here is a key condition expression. So what it's saying is when the product category, so the product category and price is less than or equal to price. Okay. So let's have a look at prod cat. So prod cat is an attribute value here for the expression, and again that's a bike, and then we've got price, which is 300. So now we can put it back in here. So we're in product category equals bike, and the price is less than 300. So it's a little bit easier to understand because you're looking at an expression that's it's not an object as such, so it's a little bit easier to understand, and then you're defining the values that are used in that expression in an object here. So again, we just run that db query command again, and we get the same result for that. So again, we do Control S to upload that to our EC2 server. Okay, so that's done, and then we'll just run it and see what happens. Okay, so we got a similar result. So we've got here 100, 200, and 300. So both techniques have given the same result, but one of them was a little bit simpler to understand. But it's good to know both ways. So whichever one you prefer, I suppose, use it. But the preferred technique that AWS recommends is to use key condition expressions. So we've covered quite a bit there. So we've used the console to create a table. We've used the console to add items, and we've seen how difficult that can be. Then we've looked at using a JSON file to batch import items into DynamoDB, and then we've looked at the two ways of querying that data using a key condition object or using a key condition expression. So that's it for now, and I'll see you in the next lab. And welcome back to Backspace Academy. This lab session is for developers, so if you're a SysOps administrator or a solutions architect, you may want to skip over this one. Or you may want to hang around and just see how things work with programming SQS and SNS. So this lab session on programming SQS and SNS with the Node.js software development kit, we're going to start with creating an SNS queue. Once we've done that, we're going to write an application using the Node.js SDK that will create SQS messages for us. And then we're going to use that application to process SQS messages. Once we've done that, we can also look at subscribing this SQS queue to an SNS topic so that we can integrate the SQS service with simple notification service, so we can send messages out from an SQS queue. So this is something that we need to consider. You could look at later on using these SNS notifications to integrate with CloudWatch, for example. We can to trigger an auto scaling instance to expand. So there's a lot of opportunities here with SQS and SNS. So programming SQS and SNS with the Node.js software development kit. Let's get into it. Welcome to this Backspace Academy lab on programming Amazon SQS and SNS using the AWS Node.js SDK. So in this lab, we're going to have two parts to it. The first part is going to look at adding the async package to our Node.js development environment. And the reason we're going to do that is that we want to be able to fire off multiple requests to our AWS SQS service and take advantage of JavaScript's asynchronous nature. So we're not going to be waiting for each one of those requests to finish before we fire off the next one. So this is a big advantage of using Node.js or using JavaScript on the browser side. So we'll look at using the async package, which makes life a lot easier as far as keeping track of those requests for us. Next, we're going to look at creating an SQS queue, and we're going to do that not using the console, but using the AWS Node.js SDK. And then we're going to look at creating some messages for that queue and deliver them to that queue. And then we're going to look at sending multiple messages using the batch method of SQS in the AWS Node.js SDK. And then we're going to look at processing and deleting SQS messages. So we're going to retrieve those messages from our SQS queue, and then we're going to process those and then delete them after we've processed them to remove them from the queue. So then in the second part of this, we're going to look at creating an SNS topic. And then we're going to create SNS messages that will go to the SQS queue, and then we'll be able to retrieve those from our SQS queue using our Node.js development environment. So this is quite important if you had, for example, some CloudWatch alarms or something like that you would want to act on, or you had some other thing that was sending messages to your application, and you didn't want your application to get overloaded, so you wanted those messages to queue up and for you to be able to process, or your application to be able to process them as needed. You can also use this quite effectively with an auto-scaling group. And so what that enables you to do is to auto-scale, so add multiple instances. For example, if you're using Amazon EC2, to create multiple EC2 instances based upon the size of your SQS queue. So as demand increases, you can gradually increase your capacity of EC2 instances. And you can do that based upon your SQS queue. And then as you've finished processing those and the demand is not there, you can start dropping off EC2 instances. Okay, so now jumping into the Atom IDE, just go into Packages, and we go into Remote Edit, browse our hosts, and then we get our development environment, connecting up to that. Okay, so the first thing we want to do is to grab our package.json file. So just grab that one. Okay, and so we're going to add another dependency here. So in this where we've got here dependencies and we've got Express, we're just going to put a comma in there and then put a dependency for async.js. So there's put in a dependency there for the async package. And then we just do Control S to save that back to our EC2 instance. And once that's saved, now what we'll do is we'll go back into Remote Edit and we'll pull in our index.js file. So again, browse hosts and connect in to our EC2 instance there. Okay, so it's connected in, so let's just pull in our index.js. Okay, so I'm just going to delete everything that's on there now and paste in the code that is in the lab notes. Okay, so let's have a look at that now. So the first thing we're going to do is we're going to require the async npm package. We're also going to require the AWS Node.js software development kit. And again, a very good note here, don't hard code your credentials. Never use your credentials in your code. Just do not do it. There is no requirement to do that. The best way to do that is to create an IAM role for your EC2 instance to access whatever services it does need to access. We're just configuring our region as before, as US East. Now we're creating a new object called AWS.SQS. Okay, so a new type of object that we're creating there, similar to our AWS.S3. Now we're going to pass some parameters to our AWS SQS call. And we've got here the queue name is going to be --lab, and that is required. That is the one thing that is required. Then we're going to pass in some attributes for that queue. So we're going to put in receive message wait time in seconds. Now that is going to allow us to do long polling. So it will, instead of wasting resources by going backwards and forwards and polling, it will allow us to wait until something is available and wait up to 20 seconds for a message to be available. So that's quite good. You should really use receive message wait time and long polling when you're using SQS. It does save your resources there. The next thing we've got here is visibility timeout. So when we retrieve a message from the queue, we don't want to automatically delete that from the queue. We want to leave it in the queue. The reason we do that is in case something goes wrong and the code crashes or whatever happens, we want that message to still be there and picked up by another instance, for example. But we don't want it to be picked up while we're processing it. So while we're processing it for a time period up to 60 seconds, our message will not be available to other instances. But after that 60 seconds, if it's not deleted, then it will be available to other instances to access and process and also delete themselves. So once we've set up those parameters, we can pass those parameters to our create queue function, which is part of the SQS SDK. And what we've got here is we're going to console log if there's an error, of course, and we're going to console log successfully created an SQS queue, and then we're going to pass the queue URL from our data object that is returned. So we just Control S to save that back to our EC2 instance. Okay, so once we've passed or uploaded our package.json and index.js files to our EC2 instance, we can use PuTTY to connect into our EC2 instance. So once we've connected in there, we want to cd into our node-js-sample directory. Now, the first thing we want to do is to install our packages that are defined in that package.json file. So we do npm install, which will add in that those npm packages for us, including the async.js package. Okay, so once we've done that, we can do node index.js. Okay, so what it's done there, it's successfully created an SQS queue. And it's outputted there the URL of that SQS queue. So that looks like it's worked perfectly. So what we'll do is we'll jump into the console, the SQS console, and we'll just see if it's actually created that. Okay, so we'll just jump into our SQS console. Okay, and there we can see we have our queue that has been created. And we can see here it's got the receive message wait time of 20 minutes that we defined, and it's got the 60 seconds of default visibility timeout period that we defined as well. So that's working fine. So we can go back to our Atom IDE now and make some more changes. So now that we've created an SQS queue using our Node.js EC2 instance, we can now look at using our EC2 instance also to create some messages to go into that queue. So first thing we're going to do is to do a call to a function, create messages here in our success callback for create queue. So once the queue has been successfully created, we're going to call create messages, which will have the queue URL passed to it. So once we've got that, so we can jump into here, we've got a function that we're going to create called create messages, which will have the queue URL for the SQS queue passed to it. Then we're going to just create a messages array, and we're going to fill it full of dummy messages, but each one of those messages will be different. Now, this is where the asynchronous nature of JavaScript or Node.js comes into play when you're doing this sort of thing. So SQS can receive messages very rapidly, and JavaScript, being asynchronous nature, can fire them off asynchronously. It doesn't have to wait for one of those responses to come back. It will just fire off requests, and it will keep doing that without waiting for the previous one to finish, which is a great thing. But unfortunately, if we did it in here with just a for next loop, for example, we would be firing off 50 of the exact same message. And the reason being is that we're going to fire off 50 requests at the same time, referencing the same parameters. And so by the time we get to the 50th message, those variables have changed, and you will ultimately, all 50 messages will have the same values in those variables sent to them, which will be identical to each other. So the async package helps us with that. So what we're going to do is we're going to do async each, which will go through each item within that array, and it will first of all console log out the content of that message that we're sending. It's telling me we've got a missing semicolon. I'll just whack that in. And then we're going to then look at passing parameters to our send message SQS SDK method. So those parameters, the two required parameters there are the message body, which will have the content of our message, and the URL, the queue URL is required. So that is what is required in the parameters, and we'll pass that to our send message, to the SQS send message method. And then we're just going to console log an error if it occurs, or we're going to console log out the data that the response data that we get if it's successful. So we just do Control S to upload that back to our EC2 instance, and once that's done, we can go into our PuTTY, into our EC2 instance again, and we can rerun our application. So that's uploaded now, so I'm just going to go back into PuTTY and do node index.js again and see what happens. Okay, that worked. So what we've got here is it's successfully created the queue as before. and then it's successfully sent a message. This is content for message 1, sending message content for message 2. So it's actually sent those messages, and then the responses have come back. So it's come back with a message ID, response metadata, and that's successful. So we've got 50 responses that have come back there, and they're all different. So they've all got a different request ID and response message ID there. So that's working fine. Async.js, the async package, has done its job, and everything's fine. So what we'll do now is we'll look at a different way. Rather than sending each one off individually, each message off individually, we can send them off as a batch. And so we'll just jump back into Atom ID, and we'll sort that out next. So now I've just updated our create messages function so that it takes advantage of batch messaging to the SQS service. So we'll just go through that. So the first thing we need to do is we need to change our messages array, because we can send up to 10 at a time, but we've got 50. So we need to send 5 lots of 10 messages at once, batches of 10. So we've got a multi-dimensional array here, so it's 5 lots of 5 by 10 to make 50. And again, we're going to asynchronously send that, or send those requests to the SQS service. So what the parameters are going to be different this time. So we're going to send the entries, which will be an array of parameters objects for each individual message, and then the same will be the QURL, which will send in the parameters. So what the entries look like is it's going to have the body as before of the message, and it's going to be given a message ID, which we're just going to call it message, and then the number of that message. And then we just go through until we've got all 10, a batch of 10 populated in our entries array. And so then we can pass those parameters, which will contain all of those 10 messages, to the send message batch method of SQS SDK. So that's how that works. So we'll just Control S that again to bring that, upload that into our EC2 instance. And once that's done, we can jump back into Putty and we can run that. So I'll just clear the screen there to make it a bit easier to read. So again, we do our node index.js to run the application. So let's have a look at that. So it looks like it's all worked fine there. So let's just go back in. So successfully created the SQS queue with that URL. Now it's sending the message. This is the content for message 0. This is the content for message 1. So it's going through and it's sending all of those through there. And then it's getting some responses back. Okay. So we've got 40, 41, 42, 43, 44, 45. So we've got all those messages coming through there. So we're getting from 40 to 49. And then we're getting from message 0 to 9. And then 10 to 19. So you can see they're not actually coming back sequentially. So this is again the asynchronous nature. So we're really taking advantage of JavaScript. So these won't always come back, number 1, batch number 1 returned, then batch number 2. So it's really taking full advantage of those resources. So you'll see that they don't necessarily come through. And the last one that came through is from 30 to 39. So again, it doesn't come through sequentially as such. So that seems to be working fine. So what we'll do now is we'll just jump into the console, and we'll just see how those messages look inside the console. Okay, so we can see there from before we had no messages available, no messages in flight. So we'll just click on refresh, and it'll be loading the queue details. And here we can see we've got 250 messages available. So I've run this a few times, and we've got quite a few messages in there. And that looks pretty good. So if we go into queue actions, we can actually view those messages and delete them if we want. So let's have a look at view delete. Okay, so we can start polling for messages, and we can view up to 10 at a time. Okay, so there we go. So we've got message 3, 5, and there they are. So we can actually go through in the console, and we can delete these if we want, which we won't do because we'll do it through our code. So that is working perfectly, not a problem. So we'll just get out that, and we'll jump back into our Atom IDE, and we'll look at processing these messages. So now what we do is we would like to retrieve those messages and create an application that is continuously polling our SQS queue for messages. But we also want it to not continuously poll when there are no messages available. So we want to take advantage of long polling, for example. So we're going to have that wait time of 20 seconds. And if it hasn't received a message, then it'll go back. And we're also going to do a thing where we can back off. So if we're polling and we find that the queue is empty, we might want to back off for a minute before we actually start polling again. So we're trying to reduce our resources, because we're continuously polling resources. We're going to be paying for those resources. So it's something we don't want to do. So if we have our SQS set up and we think that, oh, well, the maximum we can wait is around about a minute or so. So it's quite feasible if the queue is empty to back off for a minute and allow some messages to come in and wait for those. So the first thing we want to do is we're going to create a set interval. Every second is going to poll our SQS queue. And that function that it's going to do that with is receive messages. So we've got our set interval here every second, which it goes through and calls receive messages function that we're creating here. So what we're going to do is we're going to call the SQS service. So to do that, we need the queue URL. And we're also going to pass, and that is required, we're also going to pass again the maximum number of messages. So we can call up to 10 at a time. So we're going to have maximum of 10 and the visibility timeout as before and wait time of 20 as before as well. Now I'm going to put in here waiting SQS equals true. So what we want to do is that we've got a wait time of 20 seconds. So if we get in there and we do a call and we've got to wait 20 seconds for a message to arrive or a response to arrive, whereas this is firing off every second, we want to halt this. Okay, so when we're waiting for the SQS service, we don't want to continually start calling the function again. So we're just going to back that off. So we've got that if not waiting, then we continue to go. If we are waiting, we don't continue to go to receive messages anymore. So then we go to our SQS SDK receive message method, and we pass those parameters to it. And if we get an error, we will again do SQS waiting is false. So we're finished with the SQS service, and we're going to console log out that error. But if we don't get an error, then we're going to again say that the SQS polling can continue now, and we're just going to do a bit of a error check on the data, and then we're going to console log that data out, or data messages.length out to the console. If there is if we do get a successful response, but there are actually no messages, then we're going to console log out that the queue is empty, and we're going to wait for 60 seconds. And so that's where we do our back off. So if the queue is empty, we don't want to continually poll the queue every second. So we probably want to back off for a minute before we start polling the queue for any messages. So we've got there a queue counter, and that is decremented every second here until we get to 60 seconds. So if it's less than or equal to 0, then we can go through and we can start receiving messages again. So that's pretty self-explanatory. One thing you might ask, though, is that why are we actually polling? Why don't we take advantage of the asynchronous nature of JavaScript and just pull every single message out of the queue? Well, the reason we don't do that, because that would defeat the purpose of having Amazon SQS. So SQS decouples you from that. So if you were just to pull in every single message from SQS at once, then in one hit, then you would not take advantage of SQS at all, and you would probably end up crashing your EC2 instance. So the better way to do that, to manage if you can't keep up, is to have an auto scaling group of EC2 instances. So if the queue gets too big, you would pull in further EC2 instances to cope with that. And that's the way you would manage that. So we'll just Control S that to upload that to our EC2 instance, and we'll go back into PuTTY and we can run our application, and hopefully we're going to clear the queue. So node index.js again to run our application. Okay, so it's gone through and done what it's done before as far as creating a queue, creating the 50 messages and uploading those 50 messages along with the existing messages that were all there. Last time I looked, it was about 250, 300 messages that I'd put in there. So we can see through it's going through and receiving 10 messages at a time. So if we go into our SQS console, we should see the number of messages going down. So let's just have a look at that. So I just refresh. Okay, so messages available, messages in flight. Okay. And we can see there's not much happening. And there we go. So it's coming down there, messages available 5. But we've got a whole heap of messages in flight. Okay, so no messages are available, but we've still got a heap of messages that are in flight. So we'll go back into here. And we're still pulling in these messages. So they're still coming in. So the messages, the queue is still big. And we're still pulling in messages. So just Control C that to stop it. So what's happening is we are reading our messages, but we're not deleting them after we've processed them. So that's what the problem is. So next thing we need to do now is to process these messages and then delete them after we've processed them from the queue. Okay, so what we're going to do now is we're going to pass in the success callback of our receive messages function. We're going to pass a call to a new function called process messages, and we're going to pass the actual messages. So data.messages, so the response that we get from our receive messages method call from the SQS service, we're going to pass those messages to this process messages function. And what that's going to do, so this new function here is going to grab those messages and it's going to process them. Now our form of processing here is just going to be to console log out the body of that message. But in a real application, you'd probably be looking at something like processing an image or processing some file, converting a file or something like that. But for this lab, we're just going to pass out the message to the console. Then we need to delete that message from the queue. Otherwise, it's going to be there forever. We're just going to keep reading it, and then someone else is going to keep reading it and keep going on forever. So we need to call this SQS delete messages method. So what we need to pass to that in our parameters is a queue URL and the receipt handle, which we get from the content of that message. And so that uniquely identifies that message. And so we've got the queue URL and the receipt handle. The SQS delete message method can delete that message. So then we're just going to have a console log if there's an error, or we're going to have a success message there. We're going to just respond out the console log out the response from the delete message method. So we'll just Control S that to upload it to our EC2 instance again, and then we'll just jump into PuTTY and run that again. Okay, node index.js, and let's see what's happening now. Okay, it's done the same thing, and now it's not only reading the messages, it's processing them and deleting them. So we go back into our console and we refresh that. We'll see this number going, so messages available, 370, 320, 300. So we're slowly getting through all the messages now. Not many in flight, it's processing them quite quickly. One in flight. And it'll keep going until all of the messages are processed and deleted. You see a lot of times here we don't have messages in flight. So that means that we could probably have a little bit extra capacity available on an instance. So you might want to reduce that polling time down from 1 second down to 100 milliseconds, for example, if you want to take advantage more of your resources to process stuff quickly. And this is the kind of things that you would fine tune with that interval and the processing time for what you're doing. So just refresh that. And there we go. So we've got no messages available and no messages in flight. So just jump into the thing here. So SQS queue is now empty and it's waiting for 60 seconds. So it'll back off for 60 seconds and it'll just try and check the queue again. So that's all working fine. So we've successfully created a queue using the Node.js software development kit. We've added messages in batch format to that. We've read those messages back out again. We've processed and deleted those messages. So we've got all the basics of a DevOps application that you could use for whatever it be, for processing files or images or whatever it is. So that's it for part 1, and I will see you in part 2, where we'll start looking at integrating this with the AWS SNS service. I'll see you in the next lesson. Welcome to part 2 of programming Amazon SQS and SNS using the AWS Node.js software development kit. So in this part, we're going to look at using the SNS service to send messages to our SQS queue. We would do this if we had an application that would be sending off messages through SNS, or we could have, for example, CloudWatch notifications that we would want to respond to, for example. So there's a number of ways that we might want to receive SNS notifications and process those in the same way that we do a general SQS message. So we're going to set up first a subscription for an SNS topic, and then subscribe our SQS queue to that topic. So we're going to services and then SNS. And we click on Get Started. Okay, so we want to create a topic, and we're just going to call this topic _lab and give it a similar name for display name. Okay, so _lab for our topic name, and just plain backspace for our display name, and we just click on Create Topic, and that's how easy it is to create a topic in SNS using the console, not a problem. Okay, so now what we will do is we'll go into the SQS Management Console and we'll subscribe to that topic. So we go back into SQS, we click on our _lab SQS queue, and we go into Queue Actions, Subscribe Queue to an SNS topic. And then we select our _lab topic, and it will have the ARN for that topic, and we click on Subscribe. So that'll take a while to be processed. Successfully subscribed the following queue to the SNS topic _lab. Permission to receive SNS notifications was added to the queue _lab. So that's fine. So if we go into SNS now, and we go into our subscriptions, it will be added to that. So we just click on Refresh. And there we can see there is our new subscription, which is from SQS, and the endpoint of that, and the ARN of the topic that we're subscribing to. So what we can do now is, if we go back into our topic, and if we publish to that topic, it will automatically be picked up and put into the SQS queue. So let's just see if that's working. So we just go to Publish the Topic. Okay, just going to put in something there. This is a message from AWS SNS to SQS. And just leave everything as it is, and publish message. So as we can see, we've got no messages available, no messages in flight, but if we click on Refresh, and there we have, our message is now available in the queue. So it's arrived from SNS and picked up by the SQS subscription to the SNS topic. Now, jumping back into Putty, we can run our application again. So we look here and we go node-index.js, and we'll see what happens. Okay, if we scroll back up, we can see that it's gone through those, processing the 50 messages that we created as before. Everything is the same. But if we go a bit further up here, the very first message that is processed here this is a message from AWS SNS to AWS SQS. And so that's our SNS message that has been sent to the SQS service. It has been picked up here and it's been processed by our application. So everything's working fine there. So now I'm just jumping into Atom IDE again. So we're just going to replace the create messages function, which creates those 50 SQS messages. And we're just going to create our own SNS message to the SNS topic, publish that to the topic, which will be picked up by the SQS queue. So we're just going to get that now, and we delete what is there now and paste in our code. So what we need to do here is that we need to put in our target ARN, and that will be the target ARN for our SNS service. So we've got here SNS equals new AWS SNS, just as before it was AWS.SQS. So we're creating a new SNS object. And what we're doing here for our parameters is that we're going to create a message, which is just going to say this is a message from Amazon SNS. We're going to console log that out, and then we're going to do the method SNS.publish. And what we're going to pass in there will be the message and the target ARN, so we'll need to get that. And then on success, we will console log out the message that was sent. Okay, so we just need to get our target SNS ARN. And that's our target SNS ARN there. So we'll just copy that over. Okay, and then again we just Control S to upload that to our EC2 instance. And then we'll again run to PuTTY and see what happens. Okay, so I'll just Control C to clear the previous application that we were running. Okay, so we just do Node.js into that, node index.js. Okay, so it just outputted an error, and the reason for that was that our target ARN wasn't correct. So if we go into here, see target ARN, and that's because our Microsoft Word that we used to create the lab notes that we copied off is put in the wrong type of commas. So we just go back into Atom IDE, change those commas to the correct format. And again, we just upload that with Control S. And we'll run that again. Okay, so here we can have we've successfully created SQS queue, and then we've sent a message to the to be published by the SNS topic. And then we've received one message from the SQS queue after that's happened. So a message sent by SNS and then received it back. And then we've processed that message, which again, this is a message from Amazon SNS. And then we've successfully deleted that message afterwards. And now the queue's empty and we're waiting for 60 seconds. So that's about all we need to do for this part of it. So we've gone through and we've used the Node.js SDK to create a queue, to send messages to that queue, to read and process messages from that queue and delete them afterwards. And in this session, we've looked at using the AWS SNS service to create a message. First of all, create a topic, and then create or publish a message to that topic, which is then picked up by the SQS service, which is subscribed to that SNS topic. And our application in Node.js has then picked that up, processed it as before. So you can see there's going to be a lot of opportunities where you could use this to create applications that are very elastic and that can react to demand. So if you've got a queue there, you can allow stuff to build up and process it when your resources are available to process it. So I hope you enjoyed that, and I'll see you in the next topic. And welcome back to Backspace Academy. In this second lab on the API Gateway, we're going to look at creating a real application, a JavaScript application that will be hosted using Amazon S3, and it will use the API Gateway to create a dynamic component to that static website. Now, before we start using the API Gateway within our application, we need to make sure that CORS, or cross-origin resource sharing, has been enabled. The reason being is that the API domain will be different to the domain that our static website will be running on. So we need to make sure that that is allowed. So the way that we do that is we go to Resources, and then we go to Actions, and then we enable CORS. And we just click on Enable CORS. And we just replace those. And now we're ready to start writing our application. Now, to make life easier for you, I've created a GitHub repository that contains a template for using Amazon API Gateway with S3 hosted websites. So just go to the link that is there in the lab notes, and you'll get to this page. So what you need to do is you need to download that zip file and unzip it, and then open up the app.js application. Okay, so now that I've downloaded that zip file, I've extracted it, and I've gone into the JS folder, and I've opened up app.js, which will contain the application code in JavaScript. It's a very simple application. It's only 30 lines or so of code. So the first thing we've got there is a click event listener. So when someone clicks on the button on the form, that will invoke our getPet function. And so our getPet function will send that request off to our REST API that we've created. So the first thing we need to do is we need to put our API endpoint, because yours will be definitely different to that. So we go back to the management console, and we're in stages. So we don't want to go to demo. We want to go a bit further down to get for pets, and that will give us the endpoint with pets on the end of it. So what I'm going to do is just copy that over and paste that in. And there we can see it's going to have our endpoint with /pets, and we also need to put another / on the end of it. So it'll look like that. So it'll be our endpoint /pets, and then another / on the end of it. So then what we're going to do is that the application is going to get the pet ID that we input into an input box there. It's going to check that the number is okay between 1 and 3. If everything's okay, then it's going to send that request off. And so the API request will be that endpoint there plus the pet ID. So if we're looking for pet number 2, it'll be that plus 2 on the end of it. So then we do a jQuery get command, and that will we'll do a HTTP get request to that API endpoint, and there will be a callback function there that will return the data and the status of that request. So if the status was 200, it will come back with status okay, or status success. And then it will, on the next line, it will put the type, which will be cat, dog, fish, whatever. And then it'll put the price, which will be whatever the price is. And that's all it does, and that's all we need to do. So we'll just save that now that it's got our new endpoint in, and now we need to upload it all to Amazon S3 and create a static website. Okay, so just back in the AWS Management Console, let's open up the S3 Management Console, and we're just going to do that in a new tab to keep the API Gateway still there. So the first thing we need to do is to create a bucket. We'll just call it whatever we want. We'll leave everything else as it is and click on Next. We'll leave that, and we will grant public permission to this. We click on Next and create that bucket. Okay, so that bucket's been created. What we need to do now is upload our files. And we just go on next. And again, we want to have public access to this. And next, and next, and upload. And again, we need to go to properties and static website hosting. And we'll enable that. We'll put in our index.html. And we click on save. So I'm just going to go back to that and just going to open up that endpoint for the website to make sure it's working. Okay, so there we go. So we've got our website up and running very quickly. So this should be, I know I've raced through that very quickly, but again, this should be very much old hat to you. If not, go back to section 2 of the course and redo it. So here is our get pet button that we press that will invoke that get pet function. And what it will do is it will read the pet ID that we put in here. Let's just say we put in 1, and it will return the JSON details for that. So let's have a look at it. Let's put in ID 1 and get pet. Okay, so that's done that very quickly. It's gone to the API and it's had a status of success, and it's returned the dog type and the price being $249, which is exactly what we would have expected. Let's try something different. So we'll put in 3, and that should return a fish. Look at that. A 99-cent fish, and the status of that request was success, or a 200 code was returned. So what we've done, we've created an API using the API gateway, and we've also created an application using a static website that communicates with our API and provides dynamic capability for a static website. So you now fully understand API Gateway, and I'll see you in the next one. And welcome back to Backspace Academy. This lab session, this is the one for developers, so SysOps administrators and solutions architects, feel free to skip over this one. Programming Elasticache with the Node.js software development kit. So in this one, we're going to launch an Elasticache Redis cluster, and then we're going to connect into that Elasticache Redis cluster using an application written with the Node.js software development kit. And then once we've done that, we can start look at using the SDK to start sending some commands to our Elasticache Redis cluster. So programming Elasticache with Node.js software development kit. Let's get into it.
Welcome to part 1 of programming AWS Elasticache Redis. In this video, we're going to go through the Elasticache service and look at some of the features of it and where we would actually use it, the common use cases for Elasticache, and we'll also look at getting some hands-on experience in creating an Elasticache cluster using the AWS console, and then later on look at connecting to that Elasticache Redis engine to read and write information to in-memory cache. So Elasticache, it provides scalable in-memory cache. So that is different to RDS or DynamoDB, which is data that will be persisted for a significant amount of times, basically for as long as you want it to be. So Elasticache is different in that it's designed for short-term storage of information, and that information to be accessed very quickly. It currently supports the Memcached and Redis open source engines. Now, the common use cases for Elasticache would be to, first of all, to reduce load on your databases. So, for example, you might have a DynamoDB database, and you want to reduce first of all, the latency on that database, so speed up your application. You also want to reduce the amount of reads and writes to that database to reduce your costs, and again, you reduce that load on that database. And the way you would do that is that just the same as in DynamoDB, you would have storage of keys and objects of keys. The same you can do with for example, Elasticache Redis, what we're going to be using in this lab. And that will enable you to have high-speed access to that data, which will be in memory, and you can put an expiry time on that data so that it doesn't cost you significantly. And then once you've finished using it, the short term, it goes back. It will be then accessed into that long-term DynamoDB storage. Another very good use case is to manage application session state. So what we mean by that is if you have a look at the diagram there on the right hand side, we can see that we've got a user who he or she is connected in through an elastic load balancer and will be connected to one of 4 EC2 instances. So in this situation, the person is connected into the first EC2 server, and they might be on a game that has high score data. They might be filling out some user profile data in a form or whatever. So that's temporary session state storage that we want to maintain, but we don't want to maintain forever, but we want to maintain that in the short term. So what happens, for example, if that EC2 instance falls over, or that EC2 instance is part of an auto-scaling group that scales down, and all of a sudden that user is taken from that first EC2 instance and then they're rerouted into the second EC2 instance. All of a sudden that user has lost that information that would have. It might be a high score of a game. It might be form data that has been lost. So that creates a lot of problems it creates a lot of frustration for an end user, and it doesn't provide a very good user experience. So we can actually manage that session state when we've got auto-scaling instances behind a elastic load balancer, or auto-scaling groups behind an elastic load balancer, and that will make sure that when that back-end scaling is going on, that the user won't have a bad experience from that. So the first thing we need to do is to create a security group for our Redis cluster. And that security group needs to be set up so that it can allow our web servers to communicate with that Redis cluster. So the easiest way to do that is here. I've just gone through and created a security group. I won't go through how to create a security group. By this stage of the course, you know how to do that. I'll just be boring you to death by going through the process there. So mainly what we've got here is a custom TCP rule that is on the port range of 6379, which will be the port range for your Elasticache, will be the port for your Elasticache Redis cluster. And the source is going to be the web server security group there. So we're just allowing inbound on that, and the same on the outbound. We're going to allow okay, so we're going to allow everything, destination all, on the outbound. And so that's all we need to do. That the details of that are in the lab notes for this video. So just make sure that you set up that security group first, that Redis SG security group. Okay, so just jumping into the Elasticache console, we can see here we've got no clusters created yet, so we just have the introduction screen. So before we create an Elasticache cluster, we need to have a cache subnet group to launch that into. So we click on here on the left hand side before we click on getting started. We click on cache subnet groups, and we click on create cache subnet group. And so I've already created one here, and I won't go through the process again. It's all detailed in the lab notes. So I've just got here is that it's in US East 1, and that's its details there. So we've created that subnet group for our cache, and then we can use that to launch our cache cluster into that. So again, the details on how to do that are very, very straightforward. I won't go into that, and it's detailed in the lab notes. So just going back to the Elasticache dashboard. Okay, so now we click on Get Started Now. And we select our Redis, not Memcache, so we select Redis and click Next. Okay, so we won't enable replication here. We'll leave that off to keep it simple, but in a real application, you would probably look at multi-AZ. So we'll leave that off there for now. And then we'll give our cluster a name. Okay, so by default, it comes up with a large instance. So for a lab, we don't want that. We don't want to get a big bill at the end of the month. So we'll jump down to a T2 micro, which seems a little bit more suitable for us. We leave S3 location of our Redis RDB file. We'll leave that empty. So click on next. Okay, so this is where we're going to select our cache subnet group. So there it is there. And our availability zone, we'll leave that with no preference, that's fine. And our security group. So we need to select our Redis SG security group that we created previously in the VPC console. So no preference for maintenance window. We'll disable any SNS notifications. We'll click on next. And then we have a review of what we've got there. So we'll launch that cache cluster now. Okay, it's currently being created. We'll just close out of that and we can see where we're currently being created. So that's coming along nicely. So we'll just leave it there for now for the first part of our Elasticache lab. And in our next part, we're going to look at connecting into our Elasticache Redis cluster and read and write data to that and see how that works and see how we can use some of these Redis commands to get information in and out of our cluster. So I'll see you in part 2. Welcome back to part 2 of programming AWS Elasticache Redis. Okay, so the first thing we want to do is to open up PuTTY and connect into our Node.js development instance, our EC2 instance. So once we're in there, we can cd into our sample application. And what we want to do is we want to install the npm Redis package. So that will enable us to connect into our Redis cluster. Okay, and that's fine then. Okay, so now just jumping into our Atom IDE. So we just remote edit into our instance. So browse hosts, select our instance there. Okay, and then we'll just select our index.js, our sample application. And we'll just paste in from our lab notes, the code there. Now what we need to do, so we've got our port here, which is 6379. Yours should be the same. If it's not, then you'll need to change that. We need to put in our Redis endpoint in here as well. So we'll just jump into Redis, or into our Elasticache dashboard, and we click on our cache cluster and click on our node here, and we can get our endpoint there. So we'll just copy that over. And we'll put that in there. Okay, so just Control S to say that to the EC2 instance. Okay, so just jumping back into our EC2 instance in PuTTY there in our command line. So we just do node index.js to run our application and see what happens. Okay, so we've successfully connected to our Elasticache Redis cluster. So we'll just Control C out of that and we'll start looking at what other things we can do with it. Okay, so what we're going to do now is we're going to extend our application a little bit. So in that, when we've connected in here, so we're going to put in a call to another function which we're going to create called write Redis key. Now that is going to store a key called MyScore, and it's going to store it with the current high score for that person, which we've got in here 1000. So when we go back and read that, we should be able to find 1000 coming back again. So we can see here we've got, just going quickly through the application, so we're requiring async, requiring Redis here. So that's our Redis npm package that we installed. We've got our host number there, and our port number and our host address there. And then we create our Redis client on that port and host. Then we connect into that, and then we jump into our write Redis key. So what's going on here, it's client set. So set is a Redis command, and we're setting that that key, which is my score, and we're setting it to a value which is 1000. And then we're just going to console log out the response if successful or unsuccessful or whatever. We're going to console log that out when that's been completed. So in the callback there, we've got console log response. So without further ado, we do Control S and we'll get on with it. So jumping back into our PuTTY command line here. So we want to run our application. So node index.js. Okay, so we're successfully connected into the application and sending out OK message saying that we successfully wrote to that Redis cluster. So we'll just now go back and Control C out of that. And back into Atom IDE. So what we're going to do now is we're going to put an expiry time on that key when we set it. This is quite important. So if we've got applications where we've got thousands of users, we don't want to have keys flying around everywhere and stored in our Redis database without management. So we always like to put an expiry time on that key, and so I've just put in here 30 seconds. In reality, you probably want a bit more than that, but we're just putting 30 seconds for here. So in 30 seconds time, that key will expire. It will be basically deleted from that database. So Control S again to upload it, and back in again in our PuTTY console here. Again, we run our application, and then we can see that's worked fine as well. So connected through. Set that key, and it's set an expiry time on that key. And back into our Atom IDE again. So we're going to now look at putting in a call to a function that we're going to create called read Redis key. So we'll put that in the callback for write. So after we've written our key, we can then go ahead and read it afterwards. So read Redis key, and then put the name of that key that we're reading. So that will use the get Redis command. And then we just put the key name in there, which will be my high score, and it will send the response out. So the response will be the value of my score, which should output 1000 for us. So Control S, and we'll see how that works in the console. So back in the PuTTY console, we'll run that application. Okay, so we can see we've connected in, we've written that key, we've put an expiry time on it, and and we've read it, and it's outputted 1000 for us. So that worked perfectly. So what we've done so far is we've written a single key with a single value to Redis, and we've read from that. So in reality, that's probably a very simple application, and we'd probably want to do a little bit more than that. So Redis also gives us the opportunity to store objects containing multiple keys. So that's just at one single level. So you cannot have objects of objects. So you can't have that cascaded as such. So it's just objects that will contain multiple keys. And you use the HMSet command to do that. So just looking here, we've put in a call to a write Redis object function that we'll be creating. So after that console log response in our read Redis key function, we're going to create an object that's just going to have 3 keys with information in them. So this is info 1 down to this is info 3. And then we're going to call that write Redis object function that we're going to create, and we're going to pass in the name of that object called myinfo, and then the actual object itself. So then we're going to write Redis object, and we can see here we're going to use the HMSet command, which again is a command of Redis, and we're going to pass in the name of that object that we're going to save, and the value being the object itself. And then we're going to console log out the response from that. So just Control S, save that to your EC2 instance. And again, back in our PuTTY console, we'll do node index.js to run our application. Okay, so we can see there that it's connected in. It's written the key, it's put an expiry time on it, it's read that key, and now it's also written and object of keys as well. So it's gotten the OK call response there, so that's fine. And again, we'll jump back into Atom IDE, and we're going to put in a call to another function called read Redis object that we'll be creating. And we're going to pass the object name that we're looking for. So we're going to read that object and then output that object to the console. So we use the hggetAll Redis command there, and then we just pass that object name to the Redis cluster, and then we'll get a response from that Redis cluster, which will console log out to the screen. So we'll just Control S to upload that. And again, back into our PuTTY console, we'll just run our application. Okay, look at that. That's working fine. So we connected in, and we've written our object out there, and now we've read our object, and we've console logged out that object. So it's got an object containing 3 keys: info1, info2, and info3. So everything's working fine. So I hope that's given you a good understanding of how to use, or first of all, how to create a Redis cluster using the Elasticache service, and then also how to use your Node.js application to read and write store data to that Redis cluster, and to put an expiry time on that as well. And so that's Elasticache Redis for us, and I'll see you in the next lessons.
And welcome back to Backspace Academy. This session is going to be for developers. So if you're a SysOps administrator or a solutions architect, you might want to skip over this one. It's going to be a pretty technical sort of lab, this one. So we're going to be talking about programming the AWS Lambda service with Node.js. So we're not going to be using the Node.js software development kit on an application. We're going to be using the Lambda service to run our Node.js code. And that's a really good thing, because we don't have to worry about provisioning too much. This is basically a very, very abstract service where we just present code and Lambda looks after running that code for us. So the first thing we're going to do is we're going to create and test an AWS Lambda function. And then we're going to create an AWS Lambda enabled browser application. And that's going to allow us to upload data or upload images to Amazon S3, and from there it's going to set off an S3 trigger, and from that we can process our images using an AWS Lambda function. We're going to use the ImageMagick open source image processing software to do that, and we're going to run that on AWS Lambda. So pretty cool stuff, pretty in-depth. So programming Lambda with Node.js. Let's get into it.
Welcome to the Backspace Academy Lab on programming AWS Lambda. So in part 1 of this lab, we're going to look at AWS Lambda, of course, and we're going to create an AWS Lambda function. Now, Lambda is a unique service of AWS. And it's unique in that you run Node.js code on AWS services, but you don't have to actually create an architecture, and you don't have to implement any of those services to run that Node.js code. So all you have to worry about is writing code, and AWS looks after the rest. And it's a little bit similar to the S3 service, where you don't have to worry about managing EC2 instances and auto scaling and all this sort of thing, and load balancing and whatever. You just concentrate on running on writing code, which is great. So for front-end developers who just don't want to worry too much about back-end architecture, this is really good. And it's really good from the perspective that you only pay for the time that you use. So if you use one or 2 milliseconds of time, then you're really only going to be paying for that or close to it. So it's very cost effective. It's very hands-off as far as worrying about uptime and availability and that sort of thing. So it's a great service, and certainly great service for front-end, for providing a back-end to a front-end application. So once we've created that AWS Lambda function, we're going to do that in the console. We'll test that Lambda function in the console as well. Then we're going to look at getting our browser application that we created previously that used the S3 service for a back-end database. What we're going to do is invoke our Lambda function through that same browser application, and then we're also going to get that browser application to delete the Lambda function. So in effect, we're going to create Lambda Node.js server-side capabilities for our browser application. So in part 2 of this, we're going to look at another way of invoking a Lambda function, and that's through S3 events. And we'll have a look at the different types of S3 events, and then we'll look at how we can use those S3 events to automatically trigger an AWS Lambda function. And we're going to use the ImageMagick Node.js package, and we're going to use that to process images and to create a thumbnail of those images. So this could be useful, for example, if you've got a social network that has profile pictures, and they might be huge pictures, and you want to be able to process them down to a standard size. So it's quite common for that sort of function to happen, and you want that to automatically happen when the resource is available. So an S3 event would be perfect for that. Okay, so we're just now in the AWS Lambda console. So just select that from services. So just going to have a bit of a read of the stuff here. So we've got here the benefits of AWS Lambda, which is quite interesting. So we've got here respond quickly to new information. So that's, we don't have to worry about our services being overloaded and they're not going to be able to respond quickly to that new information. We can run our code without managing any infrastructure. And it's very cost effective and efficient. So we're going to be running our code only when it's needed and with no unnecessary overhead or costs. And we're going to be paying in very, very small units of time. So there's the in a nutshell what the advantages of AWS Lambda are. And so that's quite a good introduction to it. So we'll just click on now, get started now. And we're going to create our own new Lambda function. So we won't use any of these blueprints. So we're just going to create our own one. So we just skip that. Okay, so we'll give our function a name. So we're just going to call this --lambda-lab and give it a similar description. We're going to be running Node.js on our Lambda function. So we do have the option of, at this point in time, of running Java as well. So when this first was released as a service, when Lambda was first released, Node.js was the only language that you could use. So now they've added Java to that, which is quite good, and they'll probably be looking at adding more languages as time goes on. But at the time of creating this video, we have Node.js and Java. Okay, so we have another options here to hand our code over to the Lambda function. So we've got here, we can do it with an inline editor. We can upload a zip file from our local system, or we can upload a zip file from Amazon S3. So we're just going to paste in from our lab notes. So what this code is going to do is, the first thing when the function is loading, it's going to console log out a message there. It's telling us that. Now our actual Node.js code is going to be residing within exports.handler inside that function there. So what we're going to be doing is just console logging out some keys that we're going to pass to the function, and on success we're also going to console log out the first value key on there. So that's just really a very simple application. Doesn't get much more simple than that. So we'll just now have a look at the next sections that we've got to have a look at. So Lambda function handler and role. Okay, so we need to actually create a role for our AWS Lambda service to access other services and to run. So without a role, it won't actually work. So if we wanted to access S3 services, whatever, we'd need to give it an IAM role to do that. So instead of going into IAM and creating a role, which is quite tedious, and then coming back again and then selecting that role, we've already got some here that we can also already use. So we've got here create new role, and we can use basic execution role, or we can look at an S3 execution role, and that will take us into the service, and we just click on allow if we wanted to do that. So we're actually going to use the basic execution role. So we just click on basic execution role. So we just allow that. Okay, and we'll just leave the memory and timeout pretty well the same. If we had a pretty complex application, we probably want to look at increasing that timeout value, but this is doesn't get much more simpler than this, so 3 seconds should be fine. So just click on next. Okay, so here's a summary of it. So it's backspace lambda lab, Node.js, and there we go. So that's fine. Create function. Okay, and there is our function there. So now that we've created our function, we can look at testing it. So let's just click on test, and we can do that from the console here. And we've got a number of sample test event templates. So we're just going to use the hello world one, which is what we've created our Node.js application to respond to. And so it's just passing those 3 keys of value 3, value 1, and whatever. So I'm just going to change that a little bit. Okay, it's just going to pass through there. This is value 1, value 2, value 3 for those keys. So we just submit that in. Okay, so let's just have a look at that. So here we can see the summary, and what it's executed out there is upon success, context.succeed event key 1. So that's what it's outputted there upon success. So execution result succeeded, and that's what's been output there. So let's have a look at the log output here. So it started, and then it's outputted. This is value 1, this is value 2, this is value 3. So it's got there, which is what we were expecting here. So value 1 equals, this is value 1, value 2, value 3. So that's worked well, and our build duration is 100 milliseconds. And we've used 128 meg, and so that's what we will get billed for. So as you can see there, the duration of our Lambda function went for 69.75 milliseconds, and we're going to get billed for 100 milliseconds. So this is really, really good, really cost effective for us. So we're only paying down to a few milliseconds or so for our service. So this is not too useful as a function. You can't do everything from the console. It kind of defeats the purpose. So what we're going to do now is connect our application that we created before that uses the S3 service as a back-end key store database, and we're going to give that Lambda capability. So we're going to go in and into our IAM console, and we're going to need to create an IAM role for our application to access the Lambda service. So let's just go into the IAM console. So we first need to create a policy. So what we're going to do is copy our policy that we did for our service, for our application, sorry. So our Facebook backspace policy. And I'm just going to copy all of that. And just go back into policies and create a new policy. So create your own policy. And just going to copy that into there. So what I'm going to do is so we've got our statements here. So we've got our 2 statements for our S3 service to list the bucket and also to get, put and delete objects on that bucket. So I'm just going to add another one in here, which is going to give access to the AWS Lambda function. So I've just pasted that in there now. So let's have a look at that. So we've got our statement there with our multiple objects in there. So we've got our statement array, sorry, with the objects in there. So the first one we've got here is the S3 get, put and delete an object from that resource. Your bucket name will of course be different, as all bucket names need to be unique. Then we've got the same list bucket permission on that resource. So then we've added this other one in here. So what that's doing is allowing invoke, list and get Lambda calls on our Lambda resource here, our Lambda function. And so you'll need to copy your resource name over, which will be different from mine, from your Lambda page. So just copy that over and put that in here. Okay. And we just need to give that a name. Okay, so we're just going to call it Facebook-Lambda-S3. So it's giving permission to S3 and Lambda. We'll leave description out of there. It's pretty well fine for now. So just click on Create Policy. And there's our policies that's been created. So we need to now go into our roles. We need to select our Facebook backspace role that we used for our application. So I've already deleted that policy that was, or detached that policy that was on there. And so we'll put the new policy on there. So we just took attach policy and we'll select just search for Facebook. So there's our old policy there. And this is our new one, Facebook-Lambda-S3. So we'll attach that policy there. And there we go. So that's attached in there now. And so now when the application runs and uses that role, it will be able to connect into the Lambda service and invoke Lambda functions for us. So I've just jumped back into the Atom IDE, and I've opened up the folder that we used for our previous lab on IAM and S3, where we created our backspace shopping list application. And we're just going to add in a couple more buttons. So after the delete list button, we're just going to add in some more buttons in there. Okay, so they're just to invoke the Lambda function, and we're also going to get the Lambda function later on. So we'll just Control S to save that. And then we're just going to jump into our app.js, our JavaScript code. And we're just going to put in another little bit of code here in the variables. So we've got the S3 variable definition there. So we'll just put in another one for Lambda. So in the same, Lambda equals new AWS Lambda. And now we just need to create some button events for our new buttons. So I'll just paste those in now. Okay, so we're just going to be calling an invoke Lambda function and a get Lambda function. So we'll just scroll down to where we get our S3 credentials. So it's our Facebook login. And there we're creating our temporary AWS credentials. So here we're creating our S3 credentials. So we're going to do the same for Lambda. So lambda.config credentials equals new AWS web identity credentials. So the same as what we've done there. So now we just need to create our invoke Lambda function so that when we click on the button, it has somewhere to go to. So scroll down to the end here. So there's our S3 functions. We'll put it after our S3 functions. Oh no, we'll put it after our local storage functions. Okay, so we'll just put it in here. Okay, so just put that in there in its own little section. I'll just change that from S3 functions there to Lambda functions. Okay, so what are we doing here? So first of all, we've got some parameters that we need to pass. So the essential parameter there required is the name of the Lambda function, which we've got there. And then we've got the type of invocation and log type that we've got there. So then we're going to pass our payload, okay? So that, again, as we had before with our test function, it'll be doing the same thing as our test function. It'll be passing these three keys in an object to our Lambda function. And so then we can do Lambda invoke. So we can invoke that Lambda function and pass those parameters to our function. And then we've got our success and fail callbacks. So if there's an error, we'll just growl that and console log out the error. If successful, then we'll just create a little growl message just saying that was fine, and we're going to console log out the response data as well. So now we can just save that again. So we've saved both the index.html and app.js, and we can run that. So we're just going to go into now the S3 management console, and we're going to go into our bucket that we've created for our application and make sure that it's the same one that we've used in our IAM policy.
that allows S3 access. So what we're going to do is upload our new index.js and app.js. So index.js, app.js, and open that up. Okay, set details, set permissions, and make sure everything is public, and start upload. Okay, that's finished. So now we'll just go through to our website and run it. Okay, so it's done everything fine there. Retrieve local database, nothing to sync, fine. Okay, so the Facebook logging's worked fine. So now we can look at invoking our Lambda function. So we've got our two buttons that we created here. One of them works, the other one won't be doing anything. So we just click on Invoke Lambda function. Okay, so we have a message there, invoked Lambda function. So that seems to have worked fine. So if we now just click on F12, and we'll run that again. Okay, and we should be able to see something from the console now. Okay, so that looks fine. It looks like it's done exactly what we want. So it's we'll just open that up a little bit. So it's returned. This is a value from browser, which is what we're expecting, and we've got a status code of 200, which is fine. So now let's look at creating our get Lambda function as well. So that's just going to get the details of our Lambda function. So what we're going to do there is pass some parameters. The only required parameter that we need is the name of the function, of course. And we're just going to pass the name of the function to the get function method of the Lambda SDK. And again, we're going to just growl out that we got the AWS Lambda function, and we're going to console log out the response data as well. So we'll just again control S that, and then we'll just go into S3 and upload that again. And again, make sure it's public. Okay, so that's uploaded. So we'll just go back into our shopping list app and we'll refresh that. Okay, so nothing to sync, that's fine. Okay, so what we're going to do now is we're going to get that Lambda function. So we'll just click on Get Lambda function and see what happens. Okay, so we got the AWS Lambda function. So again, we'll just do F12 on that and we'll run that again and see what we get out of the console. So we'll just run that again. Okay, so we've got our AWS Lambda function, that's fine. So we'll just go back into the console and see what happens. Okay, so got something returned here from the console, which looks pretty good. So we'll just look at configuration here, and we can see here it's returned all of the details of our backspace Lambda Lambda function. So it's got the function name there, and it's got the handler for it, the role ARN, and it's running Node.js with a 3-second timeout, and that worked perfectly. So that's the end of part one of this two-part lab. So in the next part, we're going to look at a different way of triggering an AWS Lambda function, and we're going to use AWS S3 events. And so we're going to create a new Lambda function, which will have the image magic npm package in it. And what we're going to use is we're going to use that image magic package to grab images that are quite large that have been uploaded to Amazon S3 and automatically trigger when an image has been uploaded to compress that image into a thumbnail image. And we'll do that again automatically through S3 events. So I will see you in the next part. Welcome back to part 2 of programming AWS Lambda. Okay, so the first thing we need to do is we need to install Node.js on our local system. We're going to create our Node.js application on our local system first and then upload that to AWS Lambda. So we just go into here, and depending on whether you've got a 64-bit or 32-bit Windows installer there, or if you're running Mac, you can install that on there as well. So just run through and install that first. Okay, so now we need to create a Node.js application, and so we're going to create that on our local service, and then we're going to zip that and then upload that to AWS Lambda. So we go into our Node.js command prompt, which would have been installed when you installed Node.js for Windows. And then just cd into a directory that you can create if you previously created for this application. Okay, so just in there now, and so what we need to do now is to install our 2 packages that we need for our application. So that what we need is we need async as we normally do for all these Node.js applications. And we also need to install the Graphics Magic NPM module as well to enable us to use ImageMagick. So we just click on that, and that will run through and install that for us. So once we've created the skeleton for our Node.js application, we can then look at changing the index or creating an index.js file for that application, which will contain our code that we communicate with ImageMagick. So that's just all in here now, and it's also got our AWS SDK and async in there as well, requiring GM. It's using S3, so we'll just leave that as it is now. So once we've done that and we've cut and pasted in from the lab notes, we can then zip that whole folder. So what we want to do is zip the contents of the folder, which is just this here. We don't want to zip the entire or the folder itself. So when that zip file's finished, we call it index.zip, and it will look like this when it's opened up. So it'll have our index.js, and it'll have all of our node modules, which are listed in here. And so that's what our index.zip file will look like. It won't be ImageMagick and then index.js and node modules. It'll be the contents of ImageMagick, which is in that zip file. So once we've done that, we can actually go in and upload that to our AWS Lambda console. So jumping back into our AWS Lambda console, we'll create a new Lambda function. Okay, so again, we're going to skip that and we're going to create our own one. So we're just going to call this --lambda-s3-lab and give it a similar description. So this time we're not going to be editing the code in line, we're going to be uploading our zip file. So we'll just go into there and we'll upload our zip file. Okay, so there's our index.zip that we'll upload. Okay, and so now we need to go into our Lambda function role. So we don't want a basic execution role because we're going to be accessing Amazon S3 resources. So we need to actually get in here an S3 execution role. Okay, now we can just click on allow. Okay, so that's done. So back into our Lambda console, and I'm just going to go into now, so we see here we've got our Lambda S3 exec role has been created and put in there. So I'm just going to leave the memory the same, 128 meg, that should be fine, I think. And then I'm going to change the timeout though to 30 seconds. It's a much more complex application, so we'll give it a little bit more time to do its stuff. So just click on next. There we have a review of everything, so that's fine. We've got our name of it, it's Node.js.
the S3 execution role this time, and a timeout of 30 seconds this time as well. So create the function. Okay, so that's worked. That's done its stuff. That's fine. So now we need to go into the S3 management console, and we're just creating two buckets there. So one I've called here, you'll give yours a unique name. It won't be the same as ours. All buckets need to be unique. So mine I've got here, I've called backspace-lab.image, and then the next one is backspace-lab image resize. So yours need to have the same dash image on it and dash image resized. Without that, it won't be able to reference it properly. So it's okay to have the this bit here, but the end of it needs to be the same. And so what we're going to do is just upload some images to that, which I've already done. So a couple of images there of some astronauts, and hopefully when we run our application, it will put those resized images, it will resize them to thumbnails and put them into the backspace-lab image resized bucket. So now going back into our Lambda function, we can test it. So what we're going to do is click on test, and it's got our sample event template. We're not going to use that. So we're going to create our own one, and we'll paste from our lab notes in there. So we need to change our image. Okay, so change it to whatever the name of your images is, and you need to change your bucket name in here as well. So you put your bucket name in here. Okay, so just put in the name of our bucket in there and the ARN of our bucket. Okay, now we just click on submit. Okay, so that's finished. Took a bit of time. It was a lot longer than it would have taken we just did the Hello World application that we did first time. So it's a lot more complex an application. So nothing was returned, so we didn't have anything defined to return for a success log there. So that's fine. So let's have a look and see what's happened here. So it looks like we've so we've gone through that. Okay, so we've outputted there the bucket name and the object astronaut.jpg, and that looks like it's worked fine there. So it's taken, unlike the other one that took only about 70 milliseconds or so, this one's taken quite a bit of time. So the build duration is going to be 16 seconds actually. So it's a lot more complex, this one. So what we should do now is go into S3 and see whether it worked. So we can go into here. So we have our lab image resized. So we should have a resized image of our astronaut.jpg. So there we have resized astronaut.jpg. And the size of that is only 3.4K. And if we go back to our original one, and there we can see it was originally 1.1 meg. So it's done its job. It's successfully grabbed the image from that bucket, and it's processed it using ImageMagick, and it's saved it back into the image resized bucket. So now that we've tested our Lambda function, we can now use it in combination with S3 events. So we're just going to go into here and click on our source bucket, which is backspace-lab-image, or yours will be called whatever -image. And then we're going to go into properties. And then we're going to go into events and have a look at our events. So I've already got one set up here, so I'll just get rid of that one for now. So we're going to create a new event. So okay, so here it is. So we're going to give the event a name, and then we're going to select the type of event. And so here we can see the type of event. So we can see we've got a reduced redundancy lost object. So if we're using reduced redundancy service in S3 and that object goes missing, we can create a Lambda function that can or an event that will trigger in a Lambda function or whatever to recreate that object.
We've also got a number of other ones here. So when an object is removed or when an object is created. So we're going to use object created all, okay, as our event. So whenever any object goes into this bucket, it's going to trigger that object to be processed by our Lambda function. So we're just going to prefix it with JPEG. So basically, we're only going to be processing, sorry, not prefix, we'll leave prefix as it is, it's suffix actually. So anything with the extension of .jpeg, it will process. Anything else it won't bother processing. So we're only going to be processing JPEG files. And we're going to, we can actually send our event to an SNS topic, an SQS queue. So we could actually send it to a queue which would be processed by an EC2 instance, which is the old way before Lambda came along, is the way we would normally do this. But now that Lambda's here, it's a much better way of doing things, much cleaner and simpler. So we're going to choose Lambda function, and then we're going to enter our Lambda function here. And so here is our backspace -lambda -s3 function that we want to use, not use the one that we used previously. So it's this one here, the new one. Okay, and we'll just give it a name and click on save. And there we can see we've got our S3 notification for Lambda, and the event is object created all, and we're going to filter for JPEG files only, and we're going to trigger a Lambda function, and there's our Lambda function that we're going to trigger. So now we should be able to go into S3 and upload some objects to that and see what happens. So I'm just going to go into our source image bucket, and I'm just going to change the name of one of these files, which will be the same as triggering if you put in a new file. So if you change a file, it'll do the same thing. So I'm just going to go into rename that and call that astronaut number 3, and click on the tick button. Okay, so that's done. So now we go back into our, will probably take a little bit of time for this to happen, but when we go back into our resized, okay, so that was quite quick. So we've actually now resized our astronaut 3.jpg, and it's done it automatically. So as soon as we changed the name of that file, it automatically resized it for us. And so there we can see we've got 5.6K. And the original one was 1.4 meg. So that's a great thing. So we can basically, if we've got a front-end application, we can just upload images to it, and then within a few seconds we can automatically have our images processed. So it's a great service, and certainly one to consider if you're going to be running code on the back end and you don't want to worry too much about architecture. So that's the end of this lab. I hope you've enjoyed, and I hope you get to see the benefits of AWS Lambda, because it really is a game changer for AWS, and it's a great service that they've introduced. I'll see you in the next lesson.
Welcome back to Backspace Academy. In this lab, we're going to be extending our knowledge of continuous integration and continuous delivery on AWS by integrating a code pipeline with a build and test process using Mocha. And we're going to use code build, which will run the Node package manager to build that application, and then it will run a test using Mocha, and if it passes that test, then it will then forward those artifacts over to the AWS Elastic Beanstalk environment to be deployed. So this is what it's going to look like. We're going to have our pipeline, and as we've done in the past, we're going to have a source repository with our code in GitHub, and we're going to have our environment as an Elastic Beanstalk environment. But we're going to introduce a build and test process there, or build and staging process there. So we're going to be using code build and NPM to build that. and then once it's built that application, then it will pass it on to Mocha, and that will actually test that for us. And if that Mocha test passes, then the Elastic Beanstalk will have that deployed to it. Now, our deployment package that we're going to be providing to Code Pipeline will have some additional things in it that we'll need to run that build process and that build and test process. So in our build spec.yaml file, we're going to define that additional steps in there, and it's going to refer to the Mocha. So we're going to actually have that in our package.json. We're going to make sure that we actually set up and build Mocha. And once that's done, it's going to run a test, which will be located in a test.js file there. So that'll be passed over to Code Pipeline, and Code Build, or Code Pipeline, will then pass it over to Code Build, which will then run npm, which will install all of the packages that are defined in that package.json file. And then once that has been built, it will then pass it over and run Mocha, and Mocha will run that test.js. If that is successful, then it will pass it over to, or AWS Code Pipeline will pass it over to AWS Elastic Beanstalk, and that will build that, or would deploy that to that Elastic Beanstalk environment. Now, before we start building or creating our Elastic Beanstalk environment, what we need to do is go into the Backspace Academy GitHub and fork the repository for this lab. So there is a link there in the lab notes to that. So we just go in here. First off, we can star it, and then we fork it. Okay, so now that we've got that forked, what we can do is that we can actually download that zip file. Now, once that zip file has completed, we need to actually change it so that all of the code is not hidden in a folder. So first off, we'll extract that. Okay, so that's extracted, and we just need to zip that back up again. Okay, so there we've got that zipped for us, and we can save that somewhere for easy access. So let's now jump into Elastic Beanstalk and create that environment. Okay, so create new application. We'll give that a name. And create. And now we go to Actions, create an environment for this application. It's a web server environment. We'll leave the name as it is, and we need to select Node.js, and we'll upload our code. And we can create our environment now. Okay, so after 10 minutes or so, we've got our Elastic Beanstalk environment up and running. So before we jump into Code Pipeline, what we'll do is we'll have a look at some of the changes that we've made to integrate with the build and test environments here. So let's have a look first at our build spec.yaml. So we'll just have a look at that and see what's going on there. So we've got some pre-build commands here, or we've got first some install commands. So we're going to be installing Mocha. Then once we've done that, we're going to do npm install. So it'll install all of the packages that are located in our package.json file. And then we're going to be installing unit.js to run our unit tests. Once that's all done and we've got everything built, we can then run Mocha test.js, which will run a test on or using Mocha, and that will be located in test.js file. And once that is successful, then it will pass it over to, or will create all these artifacts and pass these artifacts over to Elastic Beanstalk. So let's have a look at the test.js. So that's our test. So this is not a lab on how to use Mocha or anything like that, but it's a very simple test. It's just creating a test.string here. Starts with hello, and then we're passing the word hello back to that, so it's obviously going to pass. And so if that test passes, which it most definitely will, then that will proceed to deliver that through to Elastic Beanstalk. So let's jump into Code Pipeline and create this code pipeline. So we jump into Code Pipeline and create our pipeline. Again, we get there from Services, Code Pipeline, Create Pipeline. We'll give this a name. And we can use an existing service role that we've used before if we've got one. And we'll just use our default location for the artifact store. That will be fine. And we'll click on Next. Our source provider, again, is going to be GitHub. We'll connect to our GitHub repository. Okay, so we've done that. We now need to get our repository name. So we go back into our GitHub account, and then we can select the name of that repository. So we just copy that and paste that in. And our branch will be master again. Again, we'll use the GitHub webhooks and click on Next. Now, we're going to have our build provider here. So that is going to be AWS Code Build. So we don't have a project name, so it's going to create a project for us. So we click on Create Project. So that has now opened up another window, which is going to have Code Build there. So we'll give our Code Build project a name. We won't worry about a description for it. We're going to be using a managed image. And our operating system is going to be Ubuntu. It's a Linux. And our runtime is going to be Node.js. And we'll use the latest version of that. We'll use version 10 of Node. That will be fine. So we'll select new service role, that will be fine. And we leave use build spec file as it is. And we'll continue to code pipeline. Okay, so we've successfully created backspace EB code build in code build. So that's fine. And we'll click on Next. And we're going to deploy now. So we need to, again, select Elastic Beanstalk. Select our application and our environment. And we click on Next. So there we go. So we've got our pipeline there. It's going to have our source being GitHub. And we're going to build stage there, which is going to be an AWS code build project called backspace-eb-code build. And we're going to be deploying to Elastic Beanstalk. So let's create that pipeline. Okay, so the pipeline has been created, and so now it will start to build and test that source, and hopefully it will deploy it to Elastic Beanstalk if there are no errors. Okay, so after about 10 minutes or so, it has gone through and it has built that successfully, and that it has run that test, and that it has also passed that on as a deployment. So that is great. So we've successfully created a full CI/CD pipeline going from a GitHub repository all the way through to an elastic beanstalk environment. Now, one last thing to do is to clean up so that we don't get a bill at the end of the month. So the first thing we can do is that we can edit this and delete it. And delete. So that will be deleting, successfully deleted, that's fine. And we go into our elastic beanstalk and we go into actions and we can turn, actually what we can do is we can go into our actual application and we can delete our application, which will delete those environments as well. So go into our application, delete application. Okay, and if we go into this now, it will see that it is terminating our environment for us. So that is all complete, so we won't get a bill at the end of the month, and I hope you've enjoyed this lab. It's been quite a good one, and I look forward to seeing you in the next one. Welcome back to Backspace Academy. In this lecture, we'll talk about AWS X-Ray, which is an AWS back-end service that can provide insights into how your applications are running on AWS. We'll talk about how it works. How do we modify our application code to integrate with AWS X-Ray? How do we collect information about our application's performance, and how do we pass that information on to the X-Ray service so that we can see some visualizations and graphs of this performance. We'll talk about the X-Ray daemon and what that is and how we can use that to collect information from the performance of our application and forward that onto the X-Ray service. We'll talk about the permissions that our application and the X-Ray daemon will need. We'll talk about the permissions that any users that want to access this data will need. And we'll also talk about the X-Ray console, which allows us to view very detailed, fine-grained information in the format of lists and graphs and other visualizations of our data. And finally, we'll have a look at the X-Ray development tools that are available to use with our application. The AWS X-Ray service, it will collect data about requests that are served by your application. And you can look at that data to provide very fine-grained detail around the performance of your application. It consists of a software development kit, a daemon or daemon, and the actual X-Ray console or X-Ray service. Now, the X-Ray software development kit, you need to include that with your application, and that will send trace information to an X-Ray daemon that will receive that information. So the X-Ray daemon, that will listen for UDP traffic from your application. It will buffer that data, and then in batches, it will upload it to the AWS X-Ray service. And then the AWS X-Ray service will provide data collation, analysis, and visualization tools that you can access through the AWS Management Console. Now, the X-Ray software development kit, it provides interceptors that can trace HTTP requests to your application. It will have client handlers, and that will allow you to monitor calls to AWS services. For example, calls to Amazon S3 by your application. And there will also be a HTTP client that can monitor calls to other internal or even external HTTP web services. So the combination of that will provide a very fine-grained and detailed analysis of the performance of your application. Now, the first thing we need to do is that we need to include the X-Ray software development kit in our application code. Once we've done that, the X-Ray SDK can then send information or trace information to the X-Ray daemon about what your application needs monitoring. Now, the X-Ray daemon, it will be running on its own compute resources that you need to provide. So that could be on EC2, or it could be on a Lambda function, but we'll talk more about that later. And the X-Ray daemon will get those instructions from the X-Ray software development kit, and it will start to collect data about what is to be collected. And once it's got that data, it will collate that data and it will forward it on to, or using the X-ray API, it will forward that on to the X-ray service. Once that information has been forwarded on to the X-ray service, then end users can go into the AWS Management Console, go into the X-ray console, and then you'll have a range of visualization and analysis tools available to view the performance of your application. If you want to analyze that data yourself outside of the X-ray console, there are scripts and tools that are available. You can use the AWS command line interface to download that data, for example, and use it elsewhere. Or you can use one of the many AWS software development kits to create your own application to further analyze and visualize this data yourself. After our application has run, we can go into the X-ray console and we can see here we've got a service graph, and that details segments of our application and subsegments of our application. And we can click on those and get more details about those specific parts of our application and how they are performing. So here we have some more information about the individual traces that are being monitored by the X-ray daemon. So we can see here we've got a score keep segment of our application, and that is divided up into a number of different calls to AWS services there. So we can see there that we've got game model save game that's taken quite a bit of time. So we can see there is that there is an opportunity possibly to increase the performance of our application. When you use X-ray, you break your application code down into segments, and your application code using the software development kit will forward information about those segments over to the X-ray daemon. Now, those segments can also be broken down into further sub-segments that can provide even greater granularity. The segments information provided to the X-ray daemon will include, among other things, the resource's name, details about the request, and details about the work that is being done. Now, the segment that is passed from the X-ray daemon, which will contain that application data, that is passed over to the X-ray service, will be a JSON representation of a request that your application serves. And a segment document will be information that is provided through your application through the X-ray software development kit, and that segment document will be passed on to the X-ray daemon, and that will convey information about that segment and what to monitor with the X-ray daemon. Now, the X-ray software development kit, it will gather information from request and response headers. It will gather information from the code in your application, because the SDK can actually send information about your application directly to the daemon. And it can also monitor metadata and collect that data about the AWS resources which are running your application. Now, the type of data that can be defined or collected by the X-ray daemon can be defined in the application's code through the software development kit, or in the X-ray configuration through sampling rules. And we'll talk more about those coming up. Data sent from the X-ray daemon to the X-ray service is used to create a service graph. And that will show all of the resources that are sending data, and they will appear as services or round circles in that graph. And they will be connected with edges, and those edges connect those services that interact with each other. Now, this service graph is actually a JSON document that can be retrieved from the X-ray service. And you can do that without even using the AWS console, and you can do that using either direct HTTP calls to the API, the X-ray API, or by using the command line interface or the software development kit, if you want to analyze that service graph yourself offline, for example. The X-ray daemon will collect in batches trace information to the X-ray service for analysis. Now, a trace is a collection of all of the segments and subsegments that are generated by a request. And the X-ray daemon will use a trace ID, which we use to track the path of a request through all of those segments and subsegments. Now, the service graph data, that will be retained for up to 30 days. So if you want to keep it for longer than that, you're going to have to download that yourself. And it can be retrieved using the command line interface with the get service graph command, or through the API, the X-ray API, or one of the number of software development kits. By default, the X-ray SDK will define to record the first request each second and 5% of any additional requests. So it doesn't record every single request, but it takes a sample of those requests. Now, those samples are defined in the sampling rules, and they can be created to modify that default behavior. So you can control the amount of data that you record and modify that sampling behavior on the fly. So you don't need to shut anything down. You can do it on the fly without modifying or redeploying your application code. So those sampling rules, they can be changed through the X-ray console or through the command line interface using the update sampling rule command, or the X-ray API, or one of the many software development kits. The X-ray daemon, it will listen for UDP traffic from your application through the AWS X-ray software development kit. You must provide a compute resource to run the X-ray daemon. AWS doesn't do that automatically for you. You need to make that happen. And once you've done that, the daemon endpoint must be supplied to the X-ray software development kit on your application so that it knows where to send the segment documents to. Now, the daemon compute resource must also have IAM permission to communicate with the X-ray service. So appropriate compute resources for running the daemon, you can obviously run it on an EC2 instance. You can run it as a container on an instance using ECS. You can also use the Elastic Beanstalk service to create a process on your Elastic Beanstalk EC2 instances that will run the daemon automatically for you. You can run it on AWS Lambda as a Lambda function, or using the compute resources of your application that is running on AWS Lambda. And finally, you can use it locally, or you can deploy it locally on a Linux, Mac, Windows, or Docker container environment. Now, if you're going to be using the X-ray daemon on a Lambda function, when you trace your Lambda function, the X-ray daemon will be automatically running in the Lambda environment. But the X-ray daemon, you need to consider that it consumes the maximum of 16 meg or 3% of your function's memory allocation. So if that becomes a problem for you, you need to look at doing something different. So Lambda, if you exceed your function's memory limit, will try to terminate the X-ray daemon. So to avoid that, if you want to make sure that the X-ray daemon is running all the time, you need to increase your function's memory limit or run the X-ray daemon as a separate Lambda function. In order to use the X-ray service, your users, your application, the X-ray daemon that you're running on a compute environment will all need to have permissions set up in order to use that service. So if a user wants to use the console to have a look at the data that has been visualized, they will need to have permission to get that information. So there is a managed IAM policy called AWS X-ray read-only access. And if that managed policy is applied to a user, they will be able to get access to that information through the console. The SDK and the X-ray daemon that you are running will need to have write access to the AWS X-ray service. And so there is, again, a managed IAM policy to do that. And it's called AWS X-ray daemon write access. Put trace segments is a permission that the AWS X-ray software development kit that will be running on your application will need to pass segment documents to the X-ray daemon. And put telemetry records will need that permission applied to the X-ray daemon for it to pass its telemetry records over to the AWS X-ray service. And if you want to configure encryption key settings or sampling rules, you'll need to have AWS X-ray full access. And that simply has action in your policy, X-ray, and then the wildcard symbol to give full access. If you want to do local development and testing by running the X-ray daemon on your local environment, on your local computer, then you'll need to have IAM user credentials that will have AWS X-ray full access to enable you to access those resources that are running on AWS. The X-ray service map is a visual representation of that trace data that is sent from the X-ray daemon. Now, it consists of round service nodes and edges between those connected nodes. So a service node, you can click on it to view requests generated for that node. And you can also click on the edges between nodes to view requests that are traveled between those two service node connections. You can also view a histogram of traces by duration, and that will help you to track down the problem areas within your code by looking at those long duration traces. The health of each node will be color coded, green for successful calls, red if you've got any server faults, and yellow for client errors. For example, if your client made a request for a page in a web application that didn't exist, then you'll get a 404 error, and that will come up as a yellow in the node. And finally, purple for throttling errors in your application. So here we can see we've got a service map with most of it in green, but we have something in red, which defines that we have a server fault going on there. There's a problem with our application server. We can see there we've got those service nodes and we've got the edges that connect between those related service nodes. Here we can see we've got another service node with a problem, but it doesn't exist in all of the traces, only part of those. And so part of those have got a yellow error, which means it's going to have a 400, a client-side error. For example, if your client that is accessing your application makes a request for a web page that doesn't exist. And here we see we've got a histogram of a trace, so it helps us to identify where the majority of these problems are occurring with that trace. We can also add colors to that, so we can have it so that it will show different types of traces, for example, if they're okay or if they've got errors, and they will come up as a color coding on that histogram. The trace list in the X-ray console can list traces by URL, response code, and any other data from that trace summary. The trace ID itself can be clicked to view a timeline for all of the requests that will be displayed as a hierarchy of the segments and the subsegments of that segment. Clicking on a segment or subsegment in that timeline will display a form that will have a number of different tabs. There's an overview tab that will give you the segment details, the time, the errors and faults, the request and response information. There's a resources tab, which of course will detail the resources involved in that segment. And there will be an annotations, metadata and exceptions tab as well. You can filter the data using filter expressions, and that allows you to narrow those results down. For example, if you just wanted to get the traces that had a duration of greater than or equal to 5 milliseconds and less than 8 milliseconds, that is how you would enter a filter expression for that. And you can also download or you can access the raw trace data itself in JSON format. There you can see we've got a trace list, and it has a number of fields there, being ID, age, method, response time, the URL. And you can simply, by clicking on those carets there, you can filter that or organize that based on any of those features there, being age or response time or URL or whatever. And if you click on any of those segments or sub-segments within that trace list, that will open up a hierarchy or a graph of the hierarchy of the segment and its sub-segments there as well. And it will also show the different times, and which is very good to visualize exactly where the performance is being lost or gained. And clicking on a segment within that graph, you will get this form, which will have the overview, resources, annotations, metadata, and exceptions tab there, which can again give you more information that you may need. And if the amount of results that you get is too much, and as you can see here comes a warning saying that the scanned results is more than 1,000 matching traces, so then you can go in and you can adjust your filter expression to narrow those results. And finally, you can always have a look at the raw data in JSON format there, and you can always copy and paste that into a JSON editor and have a good look at that if you wish. There are a number of development tools that are available for the X-Ray service, and those are provided through the X-Ray API. And it provides access to all X-Ray functionality through either direct HTTPS calls to the API endpoint, or by using one of the many AWS software development kits, or using the AWS command line interface. If you are going to be using the X-Ray service to monitor performance data from your application, there are a couple of put functions in the SDK that you need to be aware of, or in the API or CLI. The first one there being put trace segments, and that allows the SDK or the API or the CLI to upload segment documents to your X-Ray daemon. And that will describe exactly what you want to monitor in your application. And finally, put telemetry records. That allows the daemon to upload telemetry information or data to the X-Ray service. So that brings us to the end of a pretty complicated lecture, but the best way to learn this is to get your hands on it. And coming up next, we're going to have some labs, very detailed labs on the X-Ray service. I look forward to seeing you in those.